Hello everyone. So we are starting a Databricks series. In this Databricks series, we will try to learn about Databricks from a basic to the advanced level. In industry, how actually we use a Databricks, what kind of the problem Databricks is solving, everything we will try to cover in this particular series. As well, in Databricks, UI also has changed. So based on the latest UI, we will try to learn about Databricks completely. So in this video, let's try to understand what is a Databricks, what is a Apache Spark, why Databricks is different from just using a Spark. Let's try to understand. So what is a Databricks? Databricks is a unified analytics and data engineering platform that let you process, analyze all the kind of the data into a one single place. So what is a Databricks? It is a one kind of the unified analytics platform that will help you to manage your data, that will help you to manage your data, to process your data, to analyze your data into a one single place. What is a Databricks? It's kind of the one kind of the platform that will help you to manage your data, process your data, analyze your data into a one single platform in a better way. It is built on top of Apache Spark, but it adds many enterprise features. This is a very important point because few people thinks like Databricks is just kind of the environment for the Apache Spark. Few people think like Databricks is just kind of the environment for the Apache Spark, but Databricks is not just a Apache Spark, it has a many other features. Let's try to understand in high level. The first point is like it provides collaborative workspace for data engineer, data science and the analysts. So if you are not using a Databricks, previously what generally was happening, suppose we have a data engineer, we have a data analyst, we have a data science. So what actually they were doing, they were writing a different kind of the script in their local. They were writing different kind of the script in their local itself. Now managing this all the scripts are very tough. So how Databricks is helping? Databricks is providing a one kind of the workspace. Databricks is providing one kind of the workspace where data engineer, data analyst, data science, this all the people will work into a one single workspace. They will create their own notebook. They will try to share each developer, they can see others developer notebook, they can work together, they can share their tables, everything can be possible into one single place. So it provide a collaborative workspace. That is the first advantage. The second and the main one is like it support data lake, data warehouse and machine learning. So this is a very important point. So in a Databricks, right, in Databricks it provide a data lakehouse capability. Databricks provide data lakehouse capability. This we will try to understand in depth, but as of now you understand what is data lakehouse. It provide a capability of data lake as well as a data warehouse. It provide capability of data lake as well as a data warehouse. Means when we are saying data lake, right, we can store structure, unstructured, every kind of the data into a data lake, but with the because we have a lakehouse capability, we can also use a data warehouse capability so that we can quickly do a analytics. We can quickly do a analytics in a faster way. So this is a very important point. Databricks provide a data lakehouse capability. The third point is like Delta Lake technology for reliability, governance and the speed. So these are the main important point we have for the Databricks. So I hope you got the idea what is a Databricks. It's kind of the one analytics platform that will help you to manage, process, analyze your data into a one single place in a better way. And now we are saying Databricks is built on top of the Apache Spark. So let's try to understand what is a Apache Spark. Apache Spark is a open source distributed computing engine for processing large data set. Now let's try to understand what is Apache Spark. So suppose you have a very large data set. Suppose I have a very large data set. Now this data set if you had to process, right? So if you are using one single machine, so single machine will not be able to handle if you have a very large data set. So in this case what generally we use? We use a distributed, means we use a multiple machine. We use a multiple machine and this only we call it as a distributed framework. So when you have a very large data set, right, we try to divide and we try to process in a multiple machine, and this multiple machine we call it as a cluster. So what is a Apache Spark? This Apache Spark, this will help you to process your large data set into a distributed manner. This Apache Spark will help you to process your large data set in a distributed manner, and it process your data in a memory itself. So it is a very fast. So what is Apache Spark? Apache Spark is a one kind of the computing engine that will help you to process large data set. So here we use a multiple machine to process large data set because one single machine will not be able to handle. Apache Spark, it is very fast because it try to process the data into in memory. It can run batch streaming SQL operation. It requires you to manage cluster and storage and all. Now the question is like, when we already have a Apache Spark, that help to process large data set, then why do we need a Databricks? Why do we need a Databricks? Because Databricks is built on top of the Apache Spark, right? But why do we need a Databricks? We can use Apache Spark itself and we can process large data set and we can do all our operation, right? So let's try to understand. If you are using a Spark alone, if you are not using a Databricks, right, then you will be able to process your data in a distributed manner, right? But in this case you had to manage your cluster. So because we had to process our data into a multiple machine, right, in this case you only had to manage all those machine, and managing cluster is a very kind of the difficult and the manpower is required, so it is costly also. So if you are using only Spark, then you have to manage your cluster, you have to manage the storage, and you have to manage the integration also. But if you are using a Databricks, right? So in a Databricks, in a UI itself, what actually you can do? You will have one button to create a cluster. Auto cluster will be created. And suppose this cluster, if you are not using, then automatically the cluster will be shut down. So this kind of the different flexibility we get. It also will provide you the collaborative notebook. It also will provide you the different connectors so that you can connect with the different databases. It provide you the governance tools. So multiple advantage we get in a Databricks. Now in a Databricks we get so many advantage. If you are not using a Databricks, then you only have to maintain the cluster, and suppose for any of the job where more computation is required, then you manually have to scale the computation power. So this all the things were headache for the developer. So what Databricks has solved, it has provided a simple UI. In a simple UI itself you can create a cluster, and here we also get an option for the auto scaling. So suppose for any of the job where more computation is required, auto scaling flexibility also is available. It also provide the collaborative workspace so that the multiple teams can work together. It also provide the optimized connectors also. There are multiple features are available in a Databricks which helps developer life very easy. Now developer only has to focus on their problem statement. They do not have to focus on this managing the cluster things and all infrastructure. They do not have to worry. So this kind of the advantage we get in a Databricks. So I hope you got the idea about what is Databricks, what is Apache Spark, and how actually it is solving a problem of a Spark. In next video we will try to understand more about this, like if you are using a Spark alone and if you are not using a Databricks, then what kind of the challenges we were facing. Now let's try to discuss what kind of the different advantage we get in a Databricks as compared to the Spark alone. So first advantage is like setup and infrastructure. So suppose you are using a Spark alone, if you are not using a Databricks, right? In this case, what will happen? You have to install, you have to configure, you have to manage your own cluster. If you are using only the Spark, you are not using a Databricks, right? In this case, all the cluster you only have to manage. And managing a cluster is a very difficult and manpower is required. Because one specific team will be there, they will manage the whole cluster. So this kind of the difficulty we will get in the case of the Spark alone if you are using that. Now in the Databricks, right, it is a fully managed service. You just have to click on the create cluster and you do not have to do any kind of the manual setup. Everything will be handled by a Databricks. So that is the advantage. Now the second is the cluster management perspective. So if you are using a Spark alone, right, you manually had to scale up and scale down, and you had to monitor and you had to shut down the cluster. So if you are using a Spark alone, right? Suppose you are processing very large data set, and for this large data set, the multiple computation, multiple clusters are required, right? So manually you had to scale up this all the compute, all the machine manually. But in the case of the Databricks, right? Auto scaling cluster is available. So based on your workload, you can auto scale it, you can start it, and you can pause the compute based on your requirement. So that is the advantage we get. So that is from a cluster management perspective. From a data storage perspective, suppose you are using a Spark alone, right? So if you are using a Spark alone and you are using a data lake, from a data lake perspective, suppose for storage I am using a data lake, and suppose for processing I am using a Spark. In this case, what generally happen in data lake, all the structure, unstructured, every data we store, right? But this data, if you are using with Spark, right? Spark alone, the processing and analyzing is very difficult. Processing and analyzing is not difficult, I would say. It's very slow. Analyzing the data, processing a data is very slow in the case of the Spark alone. But if you are using a Databricks, right, it provide the Lakehouse capability. If you are using a Databricks, it provides the Lakehouse capability. It provides a capability of both a data lake as well as a data warehouse, so that you will get a capability of data lake as well as data warehouse, so that the faster processing you can do. From the governance and the security perspective, let's try to understand. If you are using a Spark alone, right, you have to handle all the permission for the file system and all. But in a Databricks, we get a Unity catalog. Unity catalog is a centralized data source where you can access all the control of your data. So that is the advantage we get. From the collaboration perspective, if you are using a Spark alone, right? If you are using a Spark alone, we have a data engineer, data analyst, right? All the people, they have to write their own code, and if they have to share, right, you have to download and you have to share. So that is the disadvantage we get. But if you are using a Databricks, multiple people, they can actually work together, they can create a notebook and they can share in a one single place. Now let's understand from the automation perspective. So if you are using a Spark alone, in this case, suppose you have created a notebook, and this notebook you want to schedule. So in this case, you require a Airflow or cron to schedule a job. But in a Databricks inbuilt automation tool we get, so that we can automate this. From a machine learning perspective, few of the deployment model you have to use from outside, but in a Databricks itself you get all these things. Now let's discuss from the optimization perspective. Spark alone, if you are using, you have to manually configure all the kind of the optimization you have to do manually. But in a Databricks, auto optimization features are available for the faster SQL and the auto tuning. From an integration perspective, if you are using a Spark alone, you have to set up the JDBC ODBC driver. But in Databricks, native connector for the Power BI, Tableau and everything is available. So this kind of the different advantage we get. So in a Spark alone, so many tasks you have to do it manually, and it takes time for the development. But in a Databricks, most of the things it Databricks handles. You only have to write your code, you have to clean data, you have to process, and you have to focus on your analyzing your data and giving the reports to the end user, and you have to focus on your data engineering, data analysis and the data science tasks. So this kind of the different advantage we get. So I hope you got idea about what is a Databricks, what is Apache Spark, how actually if you are using only the Apache Spark, then what kind of the problem we have, and how this Databricks is solving the problem. And that's it in this video. Hello everyone. So in this video we are going to see how to create a Databricks free edition account, so that we can do all our Databricks practice. So you have to come to the Google, you have to search for the Databricks free edition something, Databricks free edition. Click this. You can see Databricks free edition, it is coming. Previously Databricks community edition was different. Now Databricks free edition Databricks is providing, it looks similar to the production version. In a production, in a company, whatever the Databricks version we use, right, the similar kind of the same UI you will see in a free edition also. So we are going to use that. Click on the free edition, and after that you will see try Databricks. Click on the try Databricks here. Once you will click on the try Databricks, right, here you will get a few options. One is a use express setup, start your free trial. you do not have to click here, because if you click here, right, it will provide you 30 days free trial, I guess. After that you have to pay, means pay as you go, this will happen. And the second one is like if you want to use any of the cloud account, with that if you want to use that, you have to click here, but we are going to use a free account, right? So in the bottom you can see login for Databricks free edition, you have to click here, click here. After that you have to log in with your email ID, you have to create an account, right? So what I will do, I'll give my email ID here, click on the continue, and after that we have to pass the verification code. After that give your name, your account, country we have to select, click on the continue, protect your account. You can see verification completed. Where are you located, this is coming and it is in progress. Setting up your account. Now you can see our Databricks is ready. This is the Databricks free edition. In left side whatever the option you are seeing, right, if you will buy the Databricks paid version also, you will see the same screen, and this is the upgraded one. Whatever the previous community edition we were using, right, there you will not see this all the option. This is the new version, latest version. Here you will see the Unity catalog, here you will see the compute option. There are so many options available. So let's try to explore. Now once you create a Databricks free edition, right, you will see this particular screen. Let's try to explore. So in the left side you can see, right, we have a multiple option. Let's try to explore one by one. First option is a workspace, click on that. This is the main option. In this workspace only we will try to do all our development work. So this is the important one. In the workspace once you will click, right, you can see under this workspace we have a user. In this user option only you will try to create your all the kind of the notebook, you will try to write your PySpark code, you will try to do all your development activity. So you can see right side we have a create, right? If you click on the create, right, it will show you multiple options. If you click on the folder, so you can create any of the folder. Suppose I will give the folder name as a practical. This is the practical one folder I have created. Under this folder, right, I can create any kind of the notebook. Click on the notebook. Once I'll click on the notebook, right, one notebook will be created, and this notebook looks similar to the Jupyter notebook, right? So here we can write any kind of our code. So you can see here by default it's selected the Python, but you can also write a SQL code, you can also write a Scala code, you can also write a R language code. So these are the different language option is available that actually you can use it. Now in the right side, right, because if you had to execute any code you require a computation, you require a cluster, right? So by default if you click on this, right, connect, you will see serverless will be available, and that actually you can use it for the processing. Here in the free edition new one, right, you do not have to create any kind of the computation. By default the serverless will be available, that actually you can use it for the processing. So that is the advantage we have. Now suppose let me write any kind of the code. Suppose I will write one Python code 3 plus 4, and if you have to execute, what you have to do, shift and enter you have to press, and this notification let me block it. You can see I have written 3 plus 4 and it is executing because we are using one cluster, right, serverless, and after that it will be executed also and you will see the result. So 3 plus 4, this one is executed and we got a 7 result. Means this is the notebook where we will try to write all our PySpark code and we'll try to execute our code. And if you want to rename this notebook, right, what you have to do, you have to click here, you have to give the rename. Let me give the name as a test. Like this you can do a renaming of your notebook. If you click here, now if you click here, right, the second option is a clone. What is clone? Suppose you have created this notebook, the same kind of notebook you want, right? So what actually you can do, you can click on the clone, give the any of the name and click on the clone. The similar kind of the one more notebook will be created. You can see this is the clone option. If you click here download as, you can download this notebook. These are the multiple option we have. Similarly for this particular notebook, whatever the URL and the path, right, you will get from here. You want to rename, you can rename from here. If you want to share with another developer, right, we have a share permission option. You can click here and you can give the email ID so that the other developer can view your notebook. we have a move. If you want to move from one folder to another, we have a move option, and if you want to delete, move to trash option is available. These are the different option is available, and that actually we can use. So this is a workspace. This is an important one. In a workspace also, we can also configure the GitHub. So you can see Git folder is there, right? So we can also configure the GitHub with the Databricks. That also we can do. That also option we will explore later. And after notebook, we can also create one file. We can create a query. We can create a dashboard. Suppose any of the dashboard you want to create for the visualization. You have written one PySpark code, and after that whatever the output you are getting, right, based on that you want to create a visualization like Power BI report, we have a dashboard option also available. Then next is the Genie space. This is the important one. This is like a chat GPT. So if you write anything, right, it, so based on your whatever the table you have, right, it will explore that and you will get the result. So this is the Genie space. This also we'll try to explore later. Then we have a few of the alert option and ML flow option is available. So workspace is very important. Here only we'll try to do all our development work. Next is the recent. In a recent, whatever the notebook and any activity you will do, right, you will try to find out your notebook here in the recent option. After that we have a catalog. This is a Unity catalog. In this Unity catalog, all your data you will be able to see, and from this Unity catalog you will be able to manage your data. You will be able to, like, whatever the access control you want to do, right, you can do it from the Unity catalog itself. So this is the catalog. After that we have a job and pipeline. So suppose you want to create any of the notebook, you want to schedule on a daily basis, weekly basis, monthly basis, so you can create a job from here and you can schedule on a weekly, monthly basis. This option also available. We'll try to explore more this also. In a compute, by default serverless will be available, that actually you can use in your notebook to execute the code. Then after that, in a SQL, right, we have a SQL editor. So in a SQL editor, you will get a similar kind of the workbench like what we have in a MySQL, right? Here you can write any kind of the SQL code. You can execute any kind of the table for your ad hoc analysis and all. So SQL editor option is also available. Then we have a query. Whatever the query you are writing in a SQL editor, right, that you will find in the query. We have a dashboard. Suppose any kind of the dashboard like this you want to create, right? If I'll click on the sample one, you can see one of the dashboard which got created, which Databricks is providing. So this kind of the Databricks also we can create. So this is the dashboard option. This also we'll try to explore. You can see it is still loading because our warehouse is starting. But here you will see the multiple visualization, the sample visualization you will be able to see. So like this, the dashboard also we can create in a Databricks. You can see this is coming, right. You can see this also option. So like this, the dashboard we can create. Next is the Genie. Genie kind of the AI tool where you can explore your data. Suppose this is the option, right. You can see this is like a chat GPT. Now suppose this is a, by default few of the tables are available. Now if you want to analyze any of the table, so what actually you can do, you can type anything. So if I write show me sample sales customer table, if I write show me sales customer table, what actually it will do, this sales customer table, right, and automatically it will give you the result. So it's like a chat GPT. It will look into your table and whatever the analysis you want to do, right. Suppose if I write what are the total sales generated by each customer, if I'll click here, right, you will get the, it will automatically write a query for you and it will give you the result. You can see the user wants to see the total sales amount generated. These are the option automatically it is doing. You just have to write a text, it will give you the result and the visualization. So this is an interesting feature. We'll try to explore more also. Then we have a alert, we have a query history, we have a SQL warehouse. These are the different options are available. And now also from data engineering perspective, we have a data ingestion option. Like if you want to ingest the data from workday service, now that actually we can do it, and the job run option also available. I hope you got the idea. Please try to create the account so that we can start doing our all the practice. Hello everyone. So in this particular video we are going to discuss about Databricks Lakehouse. So Databricks provide the Lakehouse capability. So what is Lakehouse, how actually it works, everything we are going to discuss in this particular video. So let's start. The Lakehouse is Databricks data architecture that combines the best part of data lake and data warehouse in a single system. Let's try to understand this. So when we say Lakehouse, right? Lakehouse, it has derived from two words. One is lake. This lake word is coming from a data lake, and the second is the house. This house word is coming from a data warehouse. From data warehouse means lake house has a capability of both data lake as well as a data warehouse in a one single system. Now, what kind of the advantage we get when we say data lake? In a data lake, you can store any kind of the data, whether it is a structured data, whether it is a semi-structured data, or whether it is unstructured data like a video, audio, image, any kind of the data you can store into the data lake. So that is the advantage we get in a data lake. Now, what is the advantage we get in a data warehouse? In a data warehouse, we get a faster query for analytics. From analytics point of view, data warehouse provide the faster query, which is very much important. It also provide you the governance, and it also will make sure that whatever the data you will have, right, that will be a reliable data. Reliability is also one of the advantage we have in the data warehouse. Now Lakehouse concept came where we get in a single place, we get a capability of both data lake and data warehouse in a single place. So that is the Lakehouse. I hope you got the idea what is Lakehouse. Now let's try to discuss what kind of the problem we were getting when we were only using a data lake and we were only using a data warehouse. Let's try to discuss. Now when we talk about the data warehouse, right, in data warehouse what generally we do, we try to store the data in the form of the structure only. We try to store the data in the form of the structure in a tabular format, and this data actually we will use it for the analytics and for the reporting. This is what actually we do. But we know, like, we have a data in the form of the semi structure, unstructured, there are variety of the data. So alone data warehouse you cannot use. Then the data lake came. In data lake we have a flexibility where you can store structured data, you can store semi structured data, you can store unstructured, all the kind of the data into a one place. But from analytics point of view, if you will see, right, this data lake, if you will query, right, it is very slow. It is very slow from a analytics point of view. So this kind of the disadvantage we were getting. If you are using a data lake, you can store any kind of the data, but from analytics point of view it is a very slow. And also it doesn't support, if you are using only the data lake, right, it doesn't support the ACID transaction. Means it will not make sure like you have a proper schema. It will not make sure like whatever the data you are storing, that data is very reliable data. And also the transaction log, this kind of the thing actually it doesn't support. That's why we require a one system where we can have a capability of both data lake and the data warehouse in a single place. So that's why the Lakehouse came into the picture, and the Databricks provide this Lakehouse capability. I hope you got the idea what is Lakehouse and what kind of the problem it is solving. So what kind of problem it is solving? First is the data silos. So previously what actually was happening, industry, when the Lakehouse was not there, right? So what actually industry was doing? Industry was using data lake also and also data warehouse to solve this problem. So in data lake they will store all the data, then they will perform a ETL operation, they will convert into the structured data, and they will store the data into a data warehouse. So two different things the industry was using. So in this case what is happening, if you are using data lake also and data warehouse both, right, then the data duplication will happen. So this kind of the problem actually it was coming. So now Lakehouse, when it came into the picture, right, in a single system it is solving the both the problem, because it has capability of data lake as well as the data warehouse. Now the second issue with the data lake is like it is a reliability issue. So when you are using only data lake, right, it doesn't support the ACID transaction. Data warehouse support the ACID transaction, but data lake doesn't support the ACID transaction. So in this case what is happening, when we say ACID transaction, right, suppose I am using a credit card and if I'm doing any transaction, right, either the transaction should be a successful, or if any failure is coming, right, the amount should be reverted to my account. So this kind of the reliability should happen. So that kind of the advantage we get in the ACID transaction. But this data lake, it doesn't support the ACID transaction. The second is the schema enforcement. When we say schema enforcement, right, suppose data lake will not restrict you to store the data in the form of the specific schema. So but we want, like suppose id is there, right, we want id should be stored into the integer format, the whatever the amount, right, this amount should be stored into the proper integer format. We want proper schema should be there, right. So schema information also the data lake doesn't support. The third disadvantage in if you are using only the data lake, right, that is a version control. So it doesn't support the version control. So this kind of the disadvantage if you are using only the data lake. So that's why Lakehouse came into the picture, where we are combining the data lake as well as the data warehouse. So in a data warehouse we get a ACID transaction, schema enforcement, version control, right. So if you are using a Lakehouse, right, we get a advantage of data lake as well as the data warehouse, and all this kind of the problem which we were facing only in the data lake, right, it is solving that problem. The third one is the scalable and the cost. Data warehouse are very fast, but it is very expensive and limited to the structured data. If you are using only the data warehouse, right, it is a fast, but it is a very expensive, and it support only the structured data. But if you are using a data lake, right, it is very cheap and you can store any kind of the data. But if you are combining these two, right, in a lake house, you will get the fast speed also, and also all the kind of the data you can store. So that is the advantage we get in a lake house. Now we understood like what kind of the problem actually we were facing and how Lakehouse is solving this all the kind of the problem. Now let's try to understand like how actually it works. This lake how actually it works. So in a Databricks also, right, from a data storage perspective, we use a cloud. Most of the time in a industry we use a cloud. So suppose you are using a AWS, then you will use S3 for the storage, for the data lake storage, for the data lake, right. Suppose you are using Azure, then you will use a ADLS account for the storage. Now you have a data lake, you have a data lake. Now if you want a lake house capability, right, which Databricks provides, so how actually internally it works, it use a it provide a delta it provide a delta layer on top of the data lake. So we have a data lake. So how Lakehouse works, on top of this data lake, right, it provide a delta delta layer delta layer. In the delta layer, what actually happen, suppose we have stored a data in the form of the Parquet format or any open format, plus it will also create one folder. Whenever you will create a delta table, right, you will see your data that is suppose in the form of the Parquet, plus you will see one more folder that is a delta log folder. Delta log folder. In this delta log folder, once it get created, right, what generally happen, it supports all the kind of the transaction. It will support the ACID transaction, it will support all the kind of the versioning, it will support all the kind of the schema enforcement, all the kind of the thing actually it supports. So we use a data lake as it is, whatever the storage from the cloud we are using. On the top of that delta layer we use, when we use a delta layer, right, one delta log folder will be created. Once it's created, right, it will support all the kind of the ACID transaction, it will provide you the schema enforcement, it will provide you the time travel, all the versioning, it will track the every write, update and delete. So this kind of the thing actually works internally. Now let's talk about from the advantage perspective of the Databricks Lakehouse. It is a unified platform. In one single platform we have both data lake as well as a data warehouse. That is the advantage. The second is like open data format. So data we store in the form of the Parquet or Delta. So it will avoid the vendor lock-in, means we are storing the data into open data format, right? And this we can use in other system also. We are not using any specific to the Databricks storage or format of the data. We are storing the data in the form of the open format only. So that is the advantage. The third one is like it support the ACID transaction, which we have understood. It also support the time travel. It will support the performance because we have a capability of both the data warehouse, right? It's so indexing, caching, photon, this all the capability we will get. Cost efficient because for storage we are using a data lake, right? So it is cost efficient also. It supports all workload and scalable and the elastic. So these are the different advantage we get. So I hope you got the idea what is a lake house and what kind of the advantage we get in a Databricks lake house. Hello everyone. So in this particular video we are going to discuss about Unity catalog in a Databricks. So Databricks has introduced a Unity catalog concept. This is an important feature and so many problem Unity catalog is solving. So all about Unity catalog we are going to discuss in this video. Let's start. What is a Unity catalog? Unity catalog is Databricks governance and data management layer for all the data and AI asset. Think of it as a centralized system for organizing the data, for securing the data, for auditing the data, and discovering the data across all the workspace. Let's try to understand in a simple term what is a Unity catalog. What is a Unity catalog? So Unity catalog is a one centralized place. It is a one centralized place, and from this centralized place what actually you can do? You can do all your data management and the data governance activity. So Unity catalog is one centralized place, and from this place you can do, suppose you had to do a data discovery. Suppose you had to do the data discovery, like what kind of the data we have. Suppose I want to see a sales data, suppose you want to see a finance data, suppose you want to see a HR data, means all the data discovery you can do from one single place itself. So this is the Unity catalog place, and from this place you can do all your data discovery. The second advantage we get from securing perspective, from a securing perspective, like you have to secure your data, like you want, these are the users, you only want to give the read access for the production data, for the production data. So the all the access related stuff you can handle from this particular one place, that is a Unity catalog place. Now suppose you want, these are the user, only for this user you want to give a write access for the development as well and for the production as well. Now for this are the user, you only want to give a this table access. I have only limited user, for that user only I want to give this table access. Means all the access related stuff you can handle from one single place itself. So that is the advantage. So Unity catalog help, from the Unity catalog you can do all the data discovery, you can do all the access related management, and also you can do all the auditing also. Now suppose you want to know, you want to track who are the users, like I have a these are the user who are accessing, these are the tables, I have a these are the user who are accessing, these are the DBs, means you can track, I have a these are the user who is tracking this table, this DBs, this production workspace, these are the user accessing, means all the auditing stuff you can do from one single place, that is a Unity catalog workspace. So it will help from a data discovery perspective, this will help from the securing perspective, this will help from a auditing perspective, and this will also help from a organizing the data perspective. Like suppose you have to organize your prod data, QA data, dev data separately, right? So you can organize your data properly with the help of a Unity catalog. From one single place you can do all the data discovery, you can do all the access management, you can do all the auditing, you can do all the organizing data properly. So I hope you got idea what is a Unity catalog. It is a centralized system for organizing the data, for securing the data, auditing the data, and discovering the data across all workspaces. It manages tables, files, machine learning model, function, and a dashboard. Now let's try to understand, without Unity catalog, when we didn't have a Unity catalog, right, then how actually we were managing this all the stuff, and after Unity catalog what kind of the advantage we are getting. Let's try to understand so that we will get a better idea about the Unity catalog. So what generally happens whenever we work in a company, right, we create a multiple workspace. We create a multiple workspace. Suppose this is my workspace 1, this is a workspace 2. Suppose for the development activity, I have created a one workspace. Similarly, for the production activity, I have created another workspace. When I am saying a workspace, right, this is nothing but a one URL. If you open this URL, right, only the development related notebooks and the stuff you will see. Similarly, if you will open this production workspace, right, this URL, only the production related notebooks and the stuff you will see into this particular workspace. So generally we create a multiple workspace in an environment. Now when we didn't have a unity catalog, right, in that case what was happening, for if you are creating a multiple workspace, so every workspace will have their own meta store. So this workspace will have their own meta store. Similarly for this workspace, this will have their own meta store. Previously we had a meta store, now we have a unity catalog. You have to understand, right? Now the problem is like, now suppose in this meta store you are creating a table. Suppose in this meta store you are creating a table, or suppose in a production you are creating a table. Now this table, if you want to see into the development for testing, right, you will not be able to see before the unity catalog. So that kind of the problem we were having. So what generally happens in an organization, we generally create a multiple workspace. So before unity catalog, when we are creating a multiple workspace, every workspace was attached to a multiple meta store. Now for suppose if you are creating a one table in a one workspace, right, now you want to access the same table in another workspace, that was not possible in a previously. So in that case, what actually we were doing, the same kind of the table and schema we were creating a development and we were doing a testing. So that kind of the challenges we had in a before to the unity catalog. Now we have a unity catalog place. Now from one place itself, suppose you are in this workspace. Now from this workspace you want to see what are the table which is available in a production, you will be easily able to see that. So unity catalog is solving this problem. So table created in workspace were not easily shared with the others. So that was a problem we had before to the unity catalog. Access control was table only, not column and the row level. Now before to the unity catalog, what was happening, suppose I have a table. Now in this table I have a few of the column. Suppose I have a email ID column, and suppose I have a contact number column. So before to the unity catalog, I was able to give only the table level access. But now with the help of the unity catalog, you can give column level access, row level access. This will help to secure your data properly, because you don't want to give all the access for this email column, right? So this kind of the thing is possible with the help of the unity catalog. But before unity catalog, if we were only able to give the table level access, so if user has this table access, they will able to see all the columns and all. Third, from a security and the governance perspective, had to be duplicated in each workspace. So what was happening, as we were creating a multiple workspace, right, you are creating workspace 1, workspace 2, for every workspace you had to do a access control. You had to manage your access control. So separate admin is required to manage this access for the development. Separate admin is required to manage the access in a production. So the work was duplicated. But now we have a unity catalog. So from one place itself, we can do all the access control. So that is the advantage of the UC. The fourth is the lineage and auditing was poor. Hard to track who access what. So previously, when we didn't have a unity catalog, right, we didn't have a proper auditing. Like suppose this is the user, this is accessing this table. So we were not able to track it properly. Now we have a unity catalog, so all the auditing and the lineage problem it has solved. If you had a dev QA prod workspace, you had to do manually replicate the data and the permission. This already we have discussed, right? This created the data silos, governance overhead and the security risk. So this kind of the problem generally we were having when we didn't have a unity catalog. We were creating a different workspace. Now from one workspace to another workspace, if you had to see the table, you were not able to see. For every workspace you had to manage all the access. and you were not able to do all the auditing properly. So couple of challenge we had in the case of the before Unity catalog. Now everything it has solved after the Unity catalog. So you can see before Unity catalog how actually it was happening. Suppose this is my development and suppose this is my production. So this is my workspace. For every workspace I had to do a user management, like what kind of the access they will have. Every access will have their own meta store. So this meta store will have their own. Suppose development will have all the development table, production will have only the production table. There is no single place where the development and the production table we can see. If you had to see your dev table, then you had to go into the development workspace. If you had to see in a production table, then you had to go into the production workspace. So that is the thing happening. Compute for every workspace there was separate computation. So that was happening before to the Unity catalog. Now after the Unity catalog, we have a one central place. From this central place, we will have only one meta store. We will not have a multiple meta store. We will have one meta store, and from this Unity catalog you will be able to see, suppose dev tables, production table. From one place itself you will be able to see all the thing. You can do all the user management, like what kind of the access this user will have. All the access control you can do from one single place. And we have a compute for every workspace, will have a separate computation. So these are the stuff. Now let's understand the Unity catalog works architecture. Unity catalog introduced three level namespace. So in a Unity catalog we use a three level namespace. One is a catalog, then the schema, and then the table. For taking example, I have created one catalog. So the first layer will be the catalog, then the DB or schema you can say, then the table. Like this actually we create a namespace. For taking example, this catalog, suppose this is my production catalog, so I will use a production. Then DB, suppose I have one DB name is as a sales DB, and under this sales DB I have a customer table. So this is how the namespace actually be used in a Unity catalog. Similarly, suppose you want to create one catalog for the development, dev.sales.customer. So now you will be easily able to identify this table is for the development, this table is for the production with the help of the catalog. So this is the new introduction. Before Unity catalog we were only having a db.table, but now we have a catalog.db.table. So like this actually it helps. Now what are the key components? First is the meta store. It is a central governance store. So if you will understand the Unity catalog, right, the highest level of hierarchy will be the meta store. This will be a account level. This will be a account level. So account level, the meta store will be created. Under this meta store, catalog will be there. Like you can define this is a your production catalog, this is a development catalog, QA catalog, like that. After that you will define the schema. This schema is nothing but a DB, like you have a sales DB, you have a finance DB, like this the schema you will define. After that you will define the tables and the view. So this is how the components of the Unity catalog. So I hope you got the idea what is a Unity catalog, what kind of the problem actually it is solving. Now let's see how actually we can create a catalog in a Databricks. So once you will open a Databricks, right, in the left side you can see we have a catalog option. You have to click on that. Once you will click on the catalog, right, by default you can see in a my organization, right, we have a workspace, and also you will be able to see system. So these are nothing but the this is a catalog only. So this is nothing but the these are the default catalog you can see, right. So let's see how actually we can create our own catalog. So click on this, click on the create a catalog. Once you will click on the create a catalog, right, it will ask you to give the catalog name. So suppose I will give one for the development. So data dev, this is the catalog name I am giving. You can give any name. Type is standard. So we'll go with the standard one only, and use a default storage location. Click on the create. Once you will click on the create, right, you can see left side the data dev is created. Now if you want to configure the catalog, you want to manage the access and all, right, click on the configure catalog. Once you will click on the configure catalog, right, you will see this particular screen. From this particular screen you can manage all the access. You can see the first step, like access. Specify the user group and the service principal that have privilege on this catalog. So you can manage this access. So by default this will be a this one, but if you select the all workspace have access, right, means suppose I have a different workspace, so from every workspace I will be able to see this particular catalog. So if you will select the all workspace have access, right, from every workspace they will be able to see this particular catalog. So let me select this. Now after that the privilege, right, so we have select all account users, so all account user will have this access. Now if you want to grant more privileges, click here. So you will see a multiple option, like you want to give access for the execute, select, create function, whatever you want user to give, you can manage the access from here itself. Or you want to give all privilege, you can give that. Or if you want to give external use schema, you can do that. You want to manage the access, you can manage from here. Like if you want to give only the create table access, so everything you can give from here. As of now I have given the all account user will have a access. Now click on the next. Now after that if you want to do a tagging, right, so suppose this is a dev related tagging, so you can do from here. Click on the save. Now you can see our catalog is successfully created. Left side you can see data dev, and under this you can see default and the information schema is there. And if you want to create a more table from here and more DB, you can do from here. So for all the development related activity, what actually we will do, we will use this catalog, we will try to create a table here. Similarly, if you want to create a more catalog, click here, click on the create a catalog, and you can follow the same step for the production also. So like this actually we can create a catalog. I hope you got the idea. Hello everyone. So in this particular video we are going to understand about managed table versus external table in Databricks. So in a Databricks we can create a two types of the table. One is a managed table, second is a external table. So let's start. Let's understand first managed table. What is a managed table? Managed table means Databricks manages both metadata and the underlying data. So what generally will happen whenever you will create a managed table, right? Whenever you will create a managed table, in this case what will happen, whatever the metadata information of the table, right, whatever the metadata information of the table, for example, whatever the table name, whatever the table name, whatever the column name, whatever the column types, these are nothing but these are the metadata information. What is the table name, column type, these are the nothing but these are the metadata. So Databricks will manage the metadata information, and also it will manage the data also. The data also will be stored in a Databricks itself. So what is a managed table? In the case of the managed table, Databricks will manage both the metadata information as well as the underlying the data. Now in the case of the managed table, what will happen? Suppose you are performing a drop table command, drop table and the managed table. So in this case what will happen? If you are dropping a table, then in this case your table schema, your metadata schema, table schema will be deleted, as well as whatever the data, right, whatever the data is stored in the table, that also will be deleted. So what is a managed table? In the case of the managed table, we store metadata information also, and the data also is stored in the Databricks itself. And if you are dropping a table, then your table schema will be deleted, as well as the data also will be deleted. So that is a managed table. I hope you got the idea about the managed table. Now comes to the external table. Now in the case of the external table, whenever you are creating external table, right, so whatever the metadata information, right, this metadata information will be managed by a Databricks. This metadata information will be managed by Databricks, like what is the column name, column types and all, and whatever the data, right, this data will be stored into the cloud. For example, AWS, Azure, whatever the data storage you are using, right, that will be stored into the external storage. What is the external table? In external table, metadata information will be managed by a Databricks, but the actual data, right, the actual data will be stored into the cloud. Now in this case what will happen if you are performing a drop, right, if you are doing a drop table, so in this case what will happen, whatever the metadata, right, column name, column types, this table schema will be dropped, but your data still will be available in your cloud. In this case, your data will not be lost. So that is an external table. In the case of the managed table, if you are performing a drop, then your metadata will be deleted as well as your data also will be deleted, because both are managing by a Databricks itself. But in the case of the external, if you are performing a drop, right? If you are performing a drop, in this case, what will happen? Metadata will be deleted, but the data will be still available into the cloud storage. It will still available into the cloud storage. So that is a external. In the case of the managed table, metadata and the data both are managed by a Databricks, but in the case of the external, only the metadata is maintained by a Databricks. The external data will still available into the cloud storage. That is a managed table and external table. Now how to create a managed table? To create a managed table, you just have to write create table, and whatever the catalog, DB and the table name, whatever the column you want, you have to specify using a delta. So this is how actually we can create a managed table. Now how to create an external table? In this case, create table, everything you have to mention. You also have to mention the location, means where you want to store. So this is the ADLS location path, right? So this path also you have to mention. So this is how actually we can create a external table. Now let's see how actually we can create tables. So what I will do, I'll go to the workspace, and in the workspace we have created this particular folder, right? Or what actually you can do, you can create another folder from here. Click here. After that, we are going to create a new notebook. Click on the notebook here, and in this notebook, what actually we'll do, first try to do a renaming. I'll give the renaming as a practical something. This is the new notebook. Now in this practical notebook, what I will do, I will first show you how to create a managed table. So what you have to write, create let me zoom it, create table and the table name. So in a Databricks, right, how actually we give the table name, we want to store the data into our catalog, right? So we have created one of the catalog. If I show you, our catalog is a data div, right? Here only I want to store that. So we have one of the default DB, here only we want to store that. So what I will do, I'll write create table, and what is your catalog name? We have created data div, right? And after that we have a default DB available, and here I want to create a one table, that is a test table. This one, open that, open and close, and after that you have to write ID integer. Let me create a simple one, ID integer and the name string. This is the two thing, that's it. And what I will write, we want to create a delta table, right? So you have to write using delta. So what actually I am writing, create table, whatever the catalog name, and after that DB name and the table name. This is the test table I am creating. After that, column name you have to pass, and the column type also, and using delta, and you have to click on the shift and enter. Once you click on the shift and enter, right, you can see it is serverless is already available, it is starting. Now what I will do, it will create a one managed table for you. And if you want to insert anything, if I write insert into this particular table, insert into this table, and what I will do, I want to insert values 1 and the monies here, values. So what I am writing, our table is created, now we are inserting a value, insert into table. Now if you want to, once the insert will happen, we will try to see a table, whether table is created or not. So if I write select star from this particular table which we have created, right, we'll try to execute this also, select star from this particular table, So you can see we have created one table, test table, and this ID and the name is there. And in the left side in a catalog, if I'll show you, this is the catalog we have created. Under this default schema, you can see one test table is also created. test table also is created. Now this is nothing but the way we are creating, right? This is nothing but this is a manage table, because we haven't specified any the location and all, so everything it is getting stored into the Databricks itself. Now if you will do a drop table command here, if I write drop table and the table name, and if I'll execute this, right, in this case what will happen, whatever the table schema, metadata, ID and name, that will be deleted, as well as the data also will be deleted. Now if I'll show you the table again, we have executed the drop table, right? Now if I'll show you execute, you can see this table is already dropped, means both the data as well as the table both got deleted. So this is a manage table. In the manage table, whenever you are creating manage table, if you are dropping it, both data as well as the table schema will be deleted. Now how to create an external table? How to create an external table? In the case of the external table, you should have a cloud account, but as of now we are not using, right? So what actually I will show you, you had to write the same way, create table this one, and after that you have to pass the location, and you have to specify the location path like this. So in this case what will happen, uh, from this particular location it will take the data. Suppose this location where your ADLS account is located, so this particular table will point out to this particular location, and here only the data will be stored. So this is how actually we can create an external table. Only the thing is, like, we also specify the location in the case of the external table. So I hope you got the idea. Hello everyone. So in this particular video we are going to understand about the volumes in a Databricks. So in a Unity catalog we have one more concept of a volume, that only we are going to understand in this particular video. So let's start. So let's start with the tables. So till now in a Unity catalog we have understand, like, with the help of the Unity catalog we can manage our data properly. So suppose we have a table 1, table 2, table 2, table 3, like this we have a multiple table. So with the help of the Unity catalog we can easily discover what are the tables are available. We can do all the access management, like this table, who all the user will have access for this table, who all the user will have access to this table, who all the user will have access to this table, means all the access control, all the data discovery, all the auditing we can do properly with the help of the Unity catalog. So if you have a structured data, if you have a tables, then we are able to do it properly in the Unity catalog. Now when volumes comes into the picture, suppose you have a files, suppose you have a unstructured data, for example suppose you have a PDF, suppose you have a audio, suppose you have a image, suppose you have a video, suppose you have any kind of the unstructured data, suppose you have any kind of the unstructured data. In this case we want a same kind of the data governance like what we have for the tables. So to solve this, volumes come into the picture. So what is a volume? It is a logical container to store unstructured, semi-structured data, just like a folder in your data lake. Now the previously what was the problem was, so suppose you have any PDF file, or suppose you have any image file, or suppose you have any audio file, or any kind of the unstructured data you have. So what generally we were doing in a data lake, we were storing the data as it is. We were storing this all the data in a random folder. So suppose we have a HR related, resume related data is available. So in a one folder, in a raw folder, we were storing this all the data. Similarly for the finance department, we have a few image related data, so that actually we were storing into the data lake itself. Suppose we have any other related data that was unstructured data for the machine learning, like image, audio, that also we were storing here only. So previously what was happening, for all the unstructured data in a data lake we were storing into the raw folders. Now if you had to access any of this data, in this case what actually it's required, you will require the account key and the access. You will require a account key and access, or you will require a SASH token. With the help of that you will be able to access this all the data. Now the problem here is, like, suppose this is a finance team, member. Now he want to access this image. He wants to access this finance data here. Now what is actually it is required? It is required a SASH token. It is required a SASH token. So once he will get the access, right, he will be able to access all the data, because with this SASH token you will be able to access all the data, whether it is a HR data, whether it is a machine learning related data, or any department related data, right? He will be able to access with this SASH token. So that is the problem. So what generally happens, generally I want to give, if I am giving this SASH token to this finance department, right, then this team member whoever get the access, right, he should only be able to access this particular data. But as of now, once he will get the whole SASH token access, right, he will be able to see all the kind of the data which is available in another department also. Means there is no proper auditing, like who are the user who are accessing which kind of the data. To overcome this, volume came into the picture. I hope you got a high level idea about the volume. Volume, it is a logical container to store unstructured or semi-structured data, just like a folder in your data lake. It follow a namespace catalog.schema.volume. We can create two types of volume, like in a tables we create a managed table and external table, right? Similarly, we can create a two type of volume. One is a managed volume and external volume. In the case of the managed volume, what will happen, if suppose you have created a managed volume and you have uploaded a file, and if you are dropping the volume, right, then the files also will be deleted. But in the case of the external volume, if you are dropping the volume, the file will still remain same, still it will be available into your external storage. So that is the external volume. So similar to the table, we have a managed volume and a external volume concept. So volume is simple. If you have a table like structured data, then we use a table. If you have unstructured, semi-structured data, right, to govern that, we use a volume concept. Now let's discuss what kind of the problem before to the volume we were getting. The first problem was data fragmentation. So generally what was happening, suppose you have a HR related data that actually we were storing into the one raw folder, and in random place we were storing. Similarly, finance data we were storing into the another raw folder. The finance data means the data was scattered, it was not available into a one single place, and we were not able to identify who is accessing what kind of the data. So that kind of the problem we had. The second problem was security gap. So to access this data, SASH token was required. Once you will get the SASH token, right, you will be able to access any kind of the data. So this kind of the problem which we were having when we didn't have a concept of the volume. Now once the Databricks has introduced this volume concept, right, now what kind of the problem it is solving? The first is like we have a centralized namespace. Like for the table we have a catalog.schema.table, right? Similarly, catalog.schema.volume, and you will be able to access the all the unstructured files and all. The second is like access control. Now with the help of the volume you can properly control the access. Like suppose this HR department, they want, if they want access for this, so we will provide access for this only. So finance department, if they want to access for this, then we will provide access for this only. So like that the access control we can do. Metadata and the governance for the files. Now each volume has a owner, description, tags and the lineage. So that kind of the advantage we will get. File inside the volume can be cataloged and the discovered. So all the unity catalog, whatever the advantage we get, right, for the unstructured and the semi-structured data, with the help of the volume we will get the same kind of the flexibility. Now let's discuss about the advantage of volume. It is a unified governance. Now with the help of the volume we can properly govern the data, we can easily discover the data, we can improve the security because we can provide we can manage all the access. The compliance, if we are able to manage the access properly, it will file will be compliance properly, and it can support any kind of the file. So this kind of the advantage we get. I hope you got the idea about the volume. We will try to do a practical and we will try to understand more in upcoming. So hello everyone. So in previous video we understand about the volume concept. In this video we will continue, and which practically we are going to see how to create a volume. So once we'll open a Databricks, right, what actually we'll do, we'll go to the workspace, and we will create one notebook. So this is a practical one. We have created already one notebook, right? This is the practical one. If you haven't created a notebook, click on the create, click on the notebook, then the notebook will be created. So click on the this particular notebook. Now here we will see how to create a volume. So in a volume there are two types of the volume. So both the volumes we are going to understand here. So let's do one by one. So first we will understand about the manage volume. There are two types of volume we can create, and second is the external volume. Second is the external volume. Syntax is very simple. How to create a volume? What you have to write? Create volume and the volume name. So where you want to create. So generally we create a volume in the catalog only, right? So what actually we'll do, in the left side you can see we have a catalog. In this catalog we have a one data div catalog we have created. If you haven't created a catalog, click on the plus, click on the create a catalog, and you can give a catalog name, then the catalog will be created. So we already have created this data div catalog. Under this data div catalog you will get a by default one default DB. This is the DB. So what actually we are going to do, we are going to create a one volume here in a data div catalog. In a default DB we are going to create a volume. So let's do that. How to create a volume? So the syntax is very simple. Create volume, and then you have to give the uh, where you want to create a volume. So I want to create into the data div catalog dot default, and I want to give the name as a create volume data div. This is the catalog name, this is the DB name, and this is the what is the volume name. So let me give the volume name as a practical. So this is the volume I want to create. Shift and enter if you will do, right, it will start executing, and what actually it will do, you can see the volume got created. Now if you want to see that, right, go to the catalog, go to the data div, go to the default. You can see one practical volume got created. This is the volume. So you can see, right, in default we have a volume. So in a catalog, in a DB, we can create a tables also, and we can create a volume also. So table we generally use it for the structured data, but volume generally we use if you have any kind of the files. Suppose you have a JSON file, arrow file, CSV file, or suppose you have a image file, audio file. So if you want the same kind of the flexibility what we have for the table in a Unity catalog, you want it for any kind of the files, then generally we use a volume. So this is the volume we have created. A practical, click on this. This is the volume got created. Under this volume what actually we can do, we can upload any kind of the files. So you can create a directory also. Click on the create directory. Suppose I want to create a directory for the machine learning. I want to create a one directory, so that now machine learning related files we can store into this particular volume. So I have created a one volume machine learning. Similarly I will create one more directory, and that is for our raw file. So I'll give the name as a raw. So all the raw file we can store. Similarly for the finance, for the HR, all the department you can create a different directory, and there you can upload a file. Suppose for machine learning, if you want to upload any files here, click on the upload to this volume, click on the browse, and you can browse the file. So I'll go to the download. This is the image I want to upload. Click on the upload. After that what will happen, you can see the image got uploaded. Similarly if you want to upload any kind of the file, right, suppose in a raw folder I want to upload an CSV or JSON file, click on the browse, click on the any kind of the files. So let me select the JSON file, click on the upload. You can see JSON file got uploaded. Similarly if you want to upload any other file, suppose CSV file, that also you can upload. Click on the upload. So any kind of the file you can upload. Now you can see whatever the flexibility we were having for the tables, right, whatever the data governance, whatever the access control we had for the tables, right, now we also have for the volume. Like this actually we can upload the files, and whoever you want to give access, suppose you want to give only for this folder, you can give this folder access. Only for this particular image you want to give access, that also you can do. Means all the governance related stuff you can handle from a Unity catalog itself. So this is how actually we can create a file and we can do that. And now we have understand how to create a manage volume. Now if you want to create a external volume, so what is the difference between the manage volume and external volume, that also we'll understand. So let me open, this is the file, right? So as of now we have seen like how to create a manage volume. How to create a manage volume? Create volume and the volume name you have to give. In this case what will happen? Volume will be created. Now what is a manage volume? Manage volume means whatever the files we will upload, right, that will upload into the Databricks storage only. And if you are dropping this volume, how actually you can drop it? Drop volume and the volume name, whatever the volume name. If you will execute this, if you will execute this command, in this case what will happen? Whatever the files you have uploaded in a Databricks, right? So as we have created a manage volume, so in a Databricks only all the files are stored. Now if you are dropping this, then the files also will be deleted. So that is the thing you have to remember. Now what is the external volume? In the case of the external volume, what you have to write? Create volume and the volume name you have to give. As well you also have to pass the location. You also have to pass the location where you want to store. Suppose I want to store into this particular location. I want to store into the external storage. Suppose I want to store into this particular ADLS location. So like this we have also have to pass the location. In this case what will happen? If you will create this kind of the volume, right, this is an external volume because the external location also we are providing. Here we have to give the create external volume something, external, create external volume and the volume name, create external volume and the volume name, and the location you have to pass. Now in this case what will happen? If you are dropping this volume also, right, in this case what will happen? Your file will still available into your location, only the volume will be deleted. So that is the difference you have to remember. In the case of the manage, if you are dropping the volume, then the file also will be deleted, but in the case of the external volume, your files will be available in your ADLS location, but your volume will be dropped. So that is the difference you have to remember. I hope you got the idea how to create a volume, how to upload a volume, and this other stuff. Yeah, that's it in this. Thanks. Hello everyone. So till now we have understand about the Unity catalog, like how to create a table, how to create a volume, how to upload a files into the volume. This all the things we have already understood. Now we are going to start our PySpark practical. In this PySpark practical, we are going to see how to read a files, how to create a data frame, what kind of the different transformation which is available in a PySpark which we can use. Everything about the PySpark we are going to learn now. So let's start. Once you'll open a Databricks, right, left side you can see Workspace. Click on the Workspace. What actually we are going to do? We are going to create one folder. Click on the folder, and folder name I will give the PySpark tutorial something. This is the new folder actually I am creating. Under this PySpark tutorial, what actually I will do? I will create a new notebook. The notebook name you can give anything. I will give the name as a PySpark. The PySpark name actually I am giving. This is a notebook we have created, and in the compute, right, by default you will see a serverless. This also this we can use a serverless compute. Now this is the notebook we have created. Now in the left side, right, in the left side you can see we have a catalog. So let me go to the catalog. You can see we have created one data dev catalog already. Now what actually I will do for this practical, we are going to create a new catalog. Let's revise what are the things we have already learned. So click on the create a catalog. We are going to create a new catalog. The catalog name I will just give the dev. So I have given the name as a development. I'll click on the create. Now what will happen? One development catalog will be created. If you want to configure, you can do that. I'll just cut it. You can see left side we have a development catalog. So we have created one catalog. Now our catalog is available. Now what actually I will do? In this catalog, right, in the development catalog, you can see by default we have one of the DB, that is a default DB, but we want to create our own DB. So let's see first how to create a DB under this catalog. So I'll go back to the notebook. Let's first see how to create a DB. Create a DB database into that particular catalog. So I'll give the name as a create database, where you want to create a DB in the catalog, right? So first you have to pass the catalog name. I'll give the name as a development. This is the catalog we have created, right? Create database, and the DB I want to create as a data. So development catalog, I want to create a data DB. Shift and enter. If you press, you can see it is start executing. Now after that, what will happen? The spelling mistake is there. Development. Now let me execute again. Now you can see one data base got created. Now if I show into the catalog, right? In development, let's click on the development. You will see one more DB, that is a data DB. So this is the data DB we have created. Now this data DB actually we will use it for our practical. Now we have a development catalog, and also under this development catalog we have a data database. Under this data database we will create a different tables, and also we'll create a different volumes. So now let's create one volume so that we can store our CSV file. So how actually we can do that? I'll go back to the notebook again. Now let's create a volume. Create a volume. So for creating a volume, what you have to write? Create. You have to write create volume and the volume name. Where you want to create? I want to create into the development catalog. We have a data database. Under this data database we want to create one volume. So volume name I will give as a files. I will give the volume name as a files. This is the volume name I want to give. Shift and enter if you will do, right, it will start executing, and you can see volume also got created. Now if I show you in the catalog, right, in the catalog, in the development catalog, in a data database, you will see one volume will also be created. Click on the refresh catalog, development data. Left side you can see one volume got created. This is the volume. Under this volume, if you want to upload any file, you can do that. So click on the files. I clicked on the files. After clicking on the file side, what actually we'll do, we'll try to upload a files. So if you want to create a directory, right, so let me create one directory name as a orders. So this is orders related file. So this is the directory I want to create. In this orders, this is the directory we have created folder. Now we will try to upload the file. Click on this, click on the upload. Now let's try to upload a file. We will use this order CSV file. Click on the upload. Click on the upload. Now order.csv file is there. This file we have uploaded. This actually we will use it for the our PySpark practical practice. So we have done the setup. In next video we will start our PySpark practical, and we will see how to create a data frame and how to read the files. Hello everyone. So in previous video we have seen like how to create a database and how to create a volume. In this video we are going to see about how to read a CSV file and how to create a data frame. So we are going to see about the data frame. So what I will do, if you had to give any kind of the heading in a Databricks, right, what you have to do, you have to click on this text, click on this text. Now here you can write any kind of the text. So suppose I will write data frame practical. We are going to do data frame practical, right? Now if you want to do a bold, right, so you can click on the bold. Even if you want to make a heading, that also you can make a heading like h1, h2, h3. Let me select this and let me execute. Shift and enter. You can see this, like this actually you can create a heading. Now let's see how to create a data frame. So in previous video we have seen like we have uploaded one of the file. If you want to see that file, what actually you can do, you can click on this catalog, and you can also click here. You can see here catalog, right? click on this. We have uploaded a one file right in a development catalog. We have created a database, and also we have created a file volume. In this file volume we have one of the order CSV file. So this is the order CSV file. This we are going to read. Now to create a data frame, what you have to write? First we will write a df. You can give any name. We are giving one variable like a df, and what actually we will do is spark dot read dot csv, because this is a csv file, right? That's why we are writing a csv. If it is a parquet, then we can write a parquet also. After that, in a double quote, we have to pass the location. What we have written, df equal to the spark dot read dot csv, and the location we have to pass. Now to know the location, you can see this is our file, right? This actually we want to read. If you'll come here, you can see this particular symbol, right? If you'll click here, automatically you can see your location is coming. If you'll just directly click here, directly your location will come. Or if you want to know the exact location, you have to click here, and file path also you can copy. But if you click here, directly it will come. Now what we have written, df equal to the spark.read.csv, and the location we have passed. Now data frame is created. Now if I'll execute this, right, what will happen? My data frame will be created. Now if you have to read any of the data frame, then how actually you can read that? That actually we will see. So you can see it is still executing. So you can see df is executed successfully. Now if you have to read this data frame, then what you have to write? We can write df.show. That is the first way. If you write df.show like this, and if you'll execute, right, what will happen? You will be able to see your data frame. Whatever the file you have read, right, you are able to see that. You can see we are able to read this order.csv file, and with the help of the df.show we are able to read the file also. So df.show is one of the option. Now the second option, to read any of the file, right, what we have to write? We can also write a display df. If you write a display df, right, so in a tabular format you will be able to see the data. So in a df, you can see in a df.show it was showing like this, right? But when I have written display df, now you can see it is showing in the proper tabular format. So we are able to read the file, and we are able to see the data. So if you have to read the CSV file, what you have to write is spark.read.csv, and then the location you have to pass, and with the help of the df.show and the display df we will be able to read that. Now you can see we are able to read the CSV file, but as of now you can see this order ID, order date, this particular column, right, this particular row should be a header, but you can see it has created a new header for us. It's created a new column name for us like C0, C1, C2, but ideally it should be this particular. So if you had to mention like the first row itself is a header, then what you have to write? Now to handle this, what you have to write? df equal to the spark dot read dot csv, and after that location you have to pass. What is the location? This is the location, so I'll just click here. You can see location is coming. Now if you want to specify the first row is header, then what you have to write? Header equal to the true. Header equal to the true. Now once you specify header equal to true, now let's try to read the data frame, display df. Now if I'll execute, what we have passed? We have passed only the header equal to true. This is the extra thing. Now you can see, now let's see our data. Now you can see first row it has considered the header, and now it's coming proper column, order ID, order date. Previously it created a new C0, C1 like that column, right? Now it is considering the first row is header. Now we are able to read the CSV file. Now if you want to know what is the schema of this particular data frame, so like you can see in the data, right, this order ID, so ABC is nothing but it is string type, order date it is nothing but a string type, product it has considered the string type. So whenever you read a CSV file, always remember by default it consider all as a string type. So if you want to know, if you want to check what is the schema it has considered, so for that what we have to write? df.print schema. df.print schema, if you write like this, right, df.print schema, and let me execute. For executing you have to press shift and enter. Okay, so you can see when I have written df.print schema, it is showing me all the column name and also whatever their data type. So you can see all it has considered the string, but order ID it should be an integer, right? And whatever the date it should be in a date format, but it has not considered it properly. Now if you want it to be proper, if you want the order ID should be integer, means proper schema it should handle automatically, then what you have to write, you have to write one more thing. So in this case, if you want like the schema also it should consider properly, then in this case what you have to pass, you have to write df equal to the spark.read.csv location header true, and after that comma infer schema equal to the true, infer schema equal to the true. When you will pass infer schema equal to true, right, automatically it will detect the schema and it will give you the schema. If I let me execute this first and let me show you. Infer schema equal to the true, I have mentioned double equal, let me remove one and let me execute again. Now let's see what is the changes we can see. Now you can see order ID, now it is showing 1 2 3, it has automatically detected it should be an integer. Now if I show you the schema again, because we have used the infer schema, right? Now you can see order ID it has considered integer, and you can see delivery date it has considered a date, means automatically it has detected the schema and it is giving the proper schema. So how to read a data frame? Spark.read.csv, you have to pass the location, you have to pass the header equal to the true, and also you have to pass for the proper schema infer schema equal to the true. This is the thing we have to pass. Now this is the one way of creating a data frame like spark.read.csv. There is one more and the better way of creating this is like, I'll show you. Like this also we can create. What we have to mention, spark.read.format, and we have to pass the CSV. So previously we have mentioned spark.read.csv directly, right? But suppose you have Parquet file, JSON file, like this you have a different file if you want to read, then what actually we mention spark.read.format.csv, and after that we write option. In option we pass header is true, and the option header true, comma infer schema equal to the true, like this. So what we have mentioned, spark.read.format csv dot option header equal to the true, infer schema true, dot load, and we will pass the location. What is the location? This is the location, we will pass this. Now let's see we are able to read or not. So if I mention display df, let's see it's coming properly or not. Option got an X. So what we have to mention, options, we are passing multiple thing, right? Now you can see like this also we can create. So spark.read.csv, whatever previously I have shown you, that is the one way of reading the CSV file. But suppose you have a different format and then you want to read, right? Then what actually we can mention, spark.read.format, and after that whatever the file format, right, that you have to mention dot options. Here you can mention header is true, infer schema is true, and dot load, and the particular location you have to pass, and display df if you do, you will be able to see the data frame. So I hope you got the idea how to read a CSV file, how to create a data frame, and how to see the schema of the particular data frame. In next video we will see how to read a Parquet file and the JSON file. Hello everyone. Now let's see how actually we can read a JSON and the Parquet file. So previous video we have seen like how to read a CSV file and how to create a data frame. Now we are going to see how to read a JSON, or if you have any Parquet file, then how actually you can read and how actually you can create a data frame. So this we are going to see. So what I will do first, I will upload a file also. First let me give the heading. So JSON and the Parquet, this I will write here, and let me execute. You can see JSON and format. Now left side you can see you have to click here, this is the catalog, right? So we have created a development catalog, we have a data, this is the database, this is the volume we have. As of now what we have done, we only have a CSV file. Now suppose you want to add a more file here, so click here, upload to volume. Now we are going to upload a file. First we will upload a JSON file, let me show you. So So this is the JSON file we have, orders.json file. Click on the upload. What will happen now? The JSON file will be uploaded. If you will see here in the data, in the file, in order, you can see order.json file got uploaded. Now if you have to read this, what you have to write? Df equal to the, let me zoom it, df equal to the spark.read.json, spark.read.json, and in a double quote you can pass the location. So how actually you will get the location? This is the file, right? So if you click here, right, automatically this one will come. Now if you have to read this data frame, what you have to write? Display and df, display df, and let me execute this. Let's see it's working or not. Our cluster is starting. You can see it is executed, but it got failed. And what actually it is saying, like, the queries from the raw JSON CSV files are disallowed when the reference column only include the internal corrupt record column. So this kind of the issue generally comes whenever we read a JSON file. If I'll show you my JSON file, this is what I have a JSON file. Now you can see here it contains the multiple line of the JSON data, right? So if you have a this kind of the JSON file, multiple records are there, then what you have to write is part.read.json, whatever the path you have to pass, and after that comma, and you have to also pass the multi-line equal to true, multi-line equal to the true. This is what we have to pass. Now let me execute and let's see whether we are able to read or not. We have written is part.read.json path and multi-line equal to true, and we have written display df. Now you can see I am able to read my data, delivery date, order date, these are the things, right? I am able to read it properly. Now this is the one option. Now suppose you want to create a data frame by using another method, so that is a part.read.format, which we have understand, right? What you have to write is part.read.format, and here you have to mention JSON. You can use any of the method. Dot option is part.read.format JSON dot option, and here you can pass multi-line multi-line true, and dot load and this particular location. So what we have to write is part.read.format JSON dot option multi-line comma true dot load and the particular location where our file is available. Now if I will try to display df and let me execute this, what will happen? And this will start executing. Now you can see like this also we can create a data frame is part.read.format JSON option multi-line true dot load. This will also work in the similar way. Means we have a two option, either you can use spark.read.json or you can write spark.read.format. Now this is how actually we can read the JSON file. Now let's see how actually we can read the Parquet file. If you have a Parquet file, then how actually we can do. First let me upload the file. So in a data, in a files, as of now we have a CSV and the JSON, right? Let me upload one more file, that is a Parquet file. I'll browse it, and this is the orders.parquet file. Click on the upload. Now our files will be uploaded. If I'll show you in a development, this is a catalog, data, files, volume, order.parquet is there. Now if you have to create a data frame, what you have to write, df equal to the spark.read.parquet, and the particular location. What is the location? This is the location, right? This is the location we have to pass, and we will say display df. Let me execute. Let's see whether we are able to read or not. So you can see is part.read.parquet particular location, if you will pass, you will be able to read. So this is very simple, right? So like this actually we can read the CSV, JSON, Parquet, and if you have any other format also, then that particular format you have to mention and you can read that also. I hope you got the idea how to create a data frame. Hello everyone. So in this particular video we are going to see about the select transformation in a PySpark. So till now we have seen like if you have a CSV, if you have a JSON and if you have a Parquet file, then how actually we can create a data frame and how actually we can read that. So suppose we have this Parquet file. So what actually we write is part.read.parquet, and if you pass the location and if you do a display df, what will happen? You will be able to see all the data, all the column which is available. But when we work in a company, right, generally we will be having a millions and the billions of the record. In that case, we don't want to see all the data, all the columns. We want to, suppose your requirement is like you only want to see the order ID and the product and the quantity column. You don't want to see all the column. So in this case, what actually you can do, you can use a select transformation. Means whatever the column you are interested, you can select those column and you can see the result. So how actually we can use a select transformation, I will show you. So what we will write, df.select, what we have to write, df.select, and whatever the column you are interested, in a bracket you have to pass that. df.select, suppose I am interested in the order ID column, so I'll mention the order ID. And after that, suppose I am interested in the order date column, I'll mention that. And suppose I want to see the product column, this three column I want to see, so that three column I will select. And after that you can write dot show for to see the data, or you can also write a display. So if I write display in the beginning and here also, now if I'll execute this, now what will happen, only the three column it will show you, whatever the column order ID, order date, right, you can see only the three column we can see. In a previous, if you write display df, it will show you all the column, but suppose I am only interested in the three column, then what actually I can use, I can use a select transformation, and whatever the column I am interested, I can use that. This is the one way. The second way is like, if I have to write, you can also write like this, df dot select, our data frame name is a df, right, then also you can pass the column name like this, df dot order id, df dot order date, and also you can write df dot whatever the column, right. So like this also you can write, and in starting you can mention the display to see the data, display like this. Here also you can mention, and if you will execute, you will get the result. So either directly you can mention the like this, or you can mention like this also. Let's see what is the issue. I think here, let me execute again. Like this also you can mention, it will work. Now the third way is like, suppose you are using any kind of the SQL function, then the better way is like, first you have to import a library from PySpark .sql .functions, and import star, and here you have to write df dot select, and call is a one function. Under this call we can mention any of the column which you are interested. Whenever we use aggregate function, right, so this kind of the method generally helps the call, with the help of that we actually select the column. So this method also you should remember, like how to use a call. Also order date, order date means whatever the column you are interested, you can mention here, and order and the column product ID also. And after that, if you want to see the data, you can mention the dot show also, or you can mention the display also. Now if I'll execute, what will happen, I will be able to see the data. So three method I have shown you. You can see now also I can see the data. Now suppose your requirement is like this call product, whatever is there, right, this you want to rename, it is showing as a product, right, but you want to see like only product name something. So what you can mention, you can use dot alias, and whatever dot alias, and whatever the name you want, right, so product name you can mention that. Now if I'll execute, let's see the name is changing or not. You can see now the name got changed with whatever we have mentioned. So with the help of the dot alias we can also do a renaming. So I hope you got the idea about the select transformation. If you want to select a specific column, then what actually we have to use, we have to use the select transformation. Hello everyone. So in this particular video we are going to discuss about with column and with column renamed in a PySpark. So with the help of the with column, if you want to add a new column based on the certain logic, so you can do that. Suppose you want to modify the existing column, then also you can do with the help of the with column. For taking example, suppose what actually I want to create a new column. So if you have to create a new column, then what actually you will use? You will use a with column. Suppose my requirement is like I want a new column name as a ID1, and whatever the value is present into the order ID, right? I want to do a plus 100 and I want to create a new column name as a ID1. So that is possible with the help of the with column. Let me show you what what I mean. So suppose I want to create a new column. So what I have to write? D dot with column. This I will write. Now what is the column name you want to create? I want to create a new column name as a ID1. Now what is the logic? I want to put a logic if any in this particular order ID column. So we already have an order ID column. What actually I want to do in a order ID column, whatever the value is there, right? I want to do a plus 100 and that value we will store into the ID1. My requirement is like I want to create a new column ID1, and what will be the value in the ID1? Whatever the value which is already available in a order ID column, I want to do a plus 100. So that is what actually I want to do. Now if you are using a call here, then what you have to do, you have to import a library. So for that what you have to write? From PySpark dot SQL dot functions import call, you can write, or star. If you write a star, all the function will be imported. So what I have written, from PySpark.sql.function import star. What actually I am doing? df.with column ID1 I am creating, and what is the value? Order ID plus 100 I am doing. Now if I'll show you, if you want to see a data, what you can write? You can write a display and whatever the value is here. Now let me execute and let's see whether the new column is getting created or not. So if you will see, order ID is already present 1 2 3 4 5. What actually we have done, we have created a new column ID1, and you can see whatever the value rate, whatever the value which is already available in a order ID, it has done the plus 100. So you can see 101 102 103. So if you want to create a new column, what actually you can use? You can use a with column. So this is the one of the use case. So based on the certain logic, you can create a new column. Now suppose my requirement is like I want to create a new column name as a state. This is the new column I want to create, and by default I want to give the name as a random name I want to give. So how actually I can do that? So suppose I want to create a new column, so then what actually I have to write? A df.with column I have to write. What is the column name you want to create? I want to create a column name as a state, and what is the by default value you want to pass? So for that we will use a lead function, and suppose by default value you want to pass ABC. So this is the new column you want to pass into this state column, then you have to write. So lit is also one of the function, so that is available in a from PySpark.sql.function here only. So if you have used the import star, right, then again you do not have to import, you can use directly. So I am writing df.with column state lit ABC. Now if I'll execute this, so what I have to write? Display, and if I'll execute this, then what will happen? New column state should be created. The new column should be created. The name is state. Let's see whether it's working or not. So what we have done, we have created a new column state, and you can see by default value ABC it has passed. So like this actually we can use. Now suppose if you want to create a new column based on the certain logic, then we are using a with column. Now your requirement is like in the existing column itself you want to do a changes. Like suppose in order ID column, whatever the value is there, you want to do a -1. In this case, what actually you can use? You can use a with column only. So with the help of the with column, you can also do that. In an existing column only you have to do any changes, then what you have to write? You have to pass the existing column name. So order ID only I want to do a changes, and what actually you want to do a changes, that you have to specify. What actually I want to do in a order ID column, I want to do a -1. Order ID column I want to do a -1, and if you want to see the result display, we have to write, and here also I will write. And if I'll execute this, in this case what will happen? We have mentioned the order ID, right? So any transformation, whatever transformation we are doing, right, it is applying in the existing column itself. So you can see in the existing column order ID only it has done the -1. So you can see 0 1 2 3 like this it's coming. Previously it was starting from a 1 2 3 4, so it has done the -1. So if you want to create a new column based on certain logic, or if you want to modify the existing column, then what actually we use a with column. I hope you got the idea. Now let's see about the with column rename. So with the help of the with column rename, by the name itself you can understand if you want to change any of the column name. Suppose this is the order ID, right? This column I want to change the name, I want to change as a ID. So what actually I have to write? df dot with column rename, df dot with column rename, and what is the column name which you want to change? This is the order ID column, right? This I want to change as a ID. This I want to change as a ID. So I will write like this, and if you want to see the result, then you have to do display, and here also we have to write, and you have to execute. Now let's see whether it's working or not. So with the help of the with column rename, you can do the changes. You can see the order ID column got changed as a ID. So with the help of the with column rename, you can do the renaming of the existing column, and with the help of the with column, if you want to do any kind of the transformation in a column level, you can do that. If you want to add a new column, or if you want to modify the existing column, you can use a with column. I hope you got the idea. Please do practice. Hello everyone. So in this particular video we are going to see about filter transformation in a PySpark. Filter transformation is similar to in SQL we have a where condition, right? In a where condition we write a certain condition, and based on that we try to filter a data. In a PySpark we have a filter transformation. Let me show you with the example. Suppose we have one of the data frame, we are reading this order.parquet file. This particular file actually we are reading, and suppose from this particular data you only want to see where country is India. So in this case what actually you can use a filter transformation, and you can only filter a country data. Suppose your requirement is like you want to see where the payment method is debit card, you want to filter only those data, then what actually you can use a filter transformation. Let's take an example. So for that what you have to write? First you have to write a df. First you have to write a df. This is our data frame, right? Now after that we want to filter. Df dot filter you have to write. And what actually you want to filter? Df dot payment method. I want to filter df dot payment method equal to the df dot payment method, it should be equal to the debit card. Debit card card df dot payment method equal to the debit card. So from data frame we are filtering the payment method equal to the debit card. Now if you want to see a data, so what I have to write? Display, and if I will show you, if I'll execute this, now what will happen in this particular data frame? Only if the payment method is debit card, that only data you will see. Now you can see all the payment method is equal to the debit card, we can see that. Now suppose your requirement is like you want to see where the payment method is debit card and also the status is completed, so that data actually you want to see. So in this case what actually we can do? We have to use a filter only. What we will use? Df dot filter. I want to see where df dot payment method it should be equal to the debit card. Payment method should be equal to the debit card, but I also want to see where the status should be completed. So what I have to write? Df dot payment method equal to the debit card. You can write into a one bracket like this, and after that you can write one condition and the status should be complete also, right? So what I will write? Df dot status equal to the, it should be completed. So this is what actually I want. So like this we have to mention, close a bracket, and now if you want to see a data, what you have to write? Display, and let's see the result. Now in this case what will happen? We are using an AND condition. So what is the issue? Let's try to understand. Your df dot method equal to the debit card. Let me execute again. Now in this case what will happen? It will show me only those data where the payment method is debit card and also the status is completed. So AND condition means both the conditions should be satisfied, means this condition also should be satisfied and this condition also should be satisfied. Now suppose your requirement is like either the payment method should be a debit card or the status should be completed, that actually you want to see. So in this case what actually you can write, so what we will write, instead of AND condition we will write a OR condition. So for OR condition what you have to mention like this is a particular symbol we have to mention for the OR condition. Now if I'll execute, in this case what will happen, either one of the condition is satisfying, right, you will see the result. So you can see either the debit card, either the payment method is debit card or the status is completed. You can see payment method is debit card but the status is not completed, then also I can see the date. You can see the status is completed but the payment method is not debit card, means either the payment method should be a debit card or the status should be completed, you will see all those records. But in the case of the AND condition, both the condition it will satisfy, then only you will see the result. So like this actually you can do. Now suppose your requirement is like you want to see a data, where payment method ends with a D. You want to see a data where payment method ends with a D. Then how actually you can write that? I want to see df dot filter. I want to see only those record where the payment method df dot payment method ends with let's use a card. If the payment method ends with card, this will only show me those record. Now if you want to see a data display, if you have to write like this, in this case what will happen, if the payment method if is ending with the card, it will show you only those records. So you can see debit card, it is showing all the record which is ending with the card, it will show you the result. You can see credit card also coming. If it is ending with the card, it will show you the result. Now suppose your requirement is like you want to see a data where the payment method start with a C. So what you have to write, df dot payment method starts with, you want to see where if the payment method which is start with a C, only those record you want to see. So like this you have to mention df dot payment method dot starts with C. Now in this case what will happen, if the payment method, if the starting letter is C, right, then only you can see all the record. And check is coming, credit card is coming, cash is coming, so all the things which is starting with that particular letter, right, that actually we can filter. So this starts with and end it to do a data analysis, for finding, for the data cleaning, this kind of the operation, these are the useful. Now suppose my requirement is like I want to see a data where country contains IND. So if anywhere in the country column IND is present, I want to see those record either in starting, either in end. If it contains IND, I want to see the record. So in this case what you have to mention, so we will write df dot filter df dot country dot like, if it contains anywhere IND, right, that data I want to see. And if you want to see the record display, we have to write, so we want anywhere it should contain the IND, right, so what you have to write, percentage. So df dot filter df dot country dot like percent IND, if you will do, right, if anywhere IND contain in the country column, you will see the record. Let's see what are the records we have where the country contain IND. You can see few places India is coming, few places IND is coming, all those record which contains IND, right, I can see all those record with the help of this method. So like this actually we can filter a data. So with the help of the filter you can apply any kind of the condition and based on that your data will be filtered. So please do practice. Hello everyone. So in this particular video we are going to discuss about drop duplicates and distinct function in a PySpark. By the name itself we can understand drop, duplicate and distinct generally we use whenever you have a duplicate records and that records you want to remove or you want to handle, then we use a drop, duplicate and the distinct function. Now the question is, what is the difference between drop, duplicate and the distinct function? So when you will use a distinct, right, it will remove a duplicate rows, but the case is like the entire row it should match. So in this case you can see one Alice 23, this record is present 2 times, means entire row is matching. So when you will apply a distinct, right, so it will remove a duplicate record. In the case of the distinct, entire row it should match. Now the coming to the drop, duplicate. In the drop, duplicate, based on the 1 column, 2 column or more column, if you want to remove a record, then we can use a drop duplicates. Let's see with the example so that we will get a better idea. So I have a one data, this is the data, I have a column and I am creating one data frame, spark.create data frame. I am passing the data and the column. So like this also we can create a data frame. You have to pass the data, you have to give the columns, and you have to write spark.create data frame, data and the column. Now if I'll do a df.show, or you can do a display df. Let me do a display df. You will be able to see the data frame. Now here in this data frame we have a couple of duplicate records, and that records we will try to handle it. Now you can see I have a ID, I have a name and I have a age. Now you can see one Alice 23 is present here, one Alice 23 is present again here. Similarly, if you see 2 blob 34, 2 blob 34 means we have a multiple duplicate records. Now if you will use a df.distinct, right, if you will use a df.distinct, what will happen if the entire row is matching? If the entire row is matching, it will remove a duplicate record. So if I use display df.distinct, now in this case what will happen, it will remove a duplicate records. It will remove a duplicate records. Let me show you the result so that you will get better idea. Now it is executed. Now you can see one Alice 23 it is present one time, 2 Bob 34 it is present one time, then the 3 Charlie 29 is present, then 1 Alice 23, this is the duplicate record, right? All the rows is having a duplicate record, it remove this record, it remove this record, and the 6 Alice 30. So if the entire row is matching, if entire row is a duplicate, and if you want to remove that, then you can use a df.distinct. Now coming to the drop duplicate. So in the case of the drop duplicate, you can use it for the to remove a duplicate from an entire column also, entire row also, or based on the 1 column, 2 column, 3 column also you can mention. So what I will write, df.drop duplicates. If you write a df.drop duplicate, it will work similar to the distinct only. It will work similar to the distinct only, but the main difference is like in drop duplicate we can pass 1 or 2 or 3, whatever the column you want to mention, right, you can mention that. So if you write df.drop duplicate, it will work similar to the distinct, but if you want to mention a specific column, right, that actually you can mention in the drop duplicate. So suppose based on the ID I want to remove a duplicate record, or suppose based on the age I want to remove a duplicate records. So if I will do this, right, so whatever the record we have, right, whatever the age where we have a duplicate record, it will remove that. So what you have to write, df.drop duplicate, and under this, in this list you have to pass, in the list only you have to pass the column name, that you have to remember like this. So let me show you. So df.drop duplicate and age. Now based on the age we are removing. So if I show you the exact age, so 23, 34 and the 29 and 30, these are the unique record we have based on the age, right? So based on the age, unique record we can see that, and all the record we can see. So based on the specific column, if you want to remove a duplicate record, then you can go for the drop duplicate. But if you want to remove a duplicate record, if the entire row is a duplicate record, then you can go for the distinct. I hope you got the idea. It is very simple only. Hello everyone. So in this particular video we are going to understand about group by transformation in a PySpark. The group by transformation, group rows that have the same values. So it works similar to the SQL. In a SQL also we use a group by, right, with aggregation. Here also we can use in the same way. For taking example, in a state we have a couple of states are there. Now whatever the same value is there, right, that value I want to group. So for that we can use a group by. Let me show you. So what you have to write, suppose I want to use a df.group by based on the state I want to group. So what you have to write, df.group by state. Always remember group by generally we use with the aggregation. So after that, suppose if I'll use count, df.group by count, and if you want to see the result, right, so what I will write, display df.group by. So based on the state, count means what is the total number of rows. So in NY how many records are there, for CA how many records are there, that kind of the record you will get. So what actually it is doing, it is grouping all the state values. So you can see NY, whatever the NY is present into the state column, right, it group. So and it is showing the records. So for NY we have a 2 records, for CA we have a 2 records, for TX we have a 2 records. So like that actually in a column whatever the values are there, right, and that values if you want to group, then we can use a group by. Always remember group by we use aggregation function. So count is one of the aggregation, so that we have used. So suppose based on each state you want to find out what is the total salary. So how actually you can do that? So what I will write, df dot group by, I want to group based on the state only. So I will use a state, and after that I want to apply a aggregation. So what I will write, dot aggregation, and here you have to pass a, suppose based on the salary, right. So what I will write, salary, and after that colon. Suppose you want to find out the sum, right, then you have to mention the sum. So what actually you have to write, df dot group by state dot aggregation, sum of salary you want to do. So you have to write like this in a form of the dictionary. Now if I will do a display here, so what will happen, based on each state it will group, and also it will find out the total salary, sum of the salary. Let me execute this. So based on each state what is the total salary it is showing me. So if I show you in the actual data frame, right, so for the ID1 NY we have a salary 2000. Similarly for ID3 NY we have a 3000. 2000 plus 3000, 5000, right. So now we have grouped that, and now we can see for NY we have a total salary 5000. So like that actually we can use that. Similarly if you want to find out the average, salary, so what actually you can do that, display df dot group by which particular column, aggregate salary. Suppose you want to do a average, right, so you have to mention the average here. Now what will happen, whatever the average value, right, that we can see based on each state. Similarly if you want to find out the max value based on the each state, what you have to write, here you have to mention the max. Here you have to mention the max based on the each state whatever the maximum salary, right. So in NY we have a maximum salary 3000, in a CA we have a 2500. Let's see it's working properly or not. For NY you can see we have a 2 record, one is 2000, second is the 3000, maximum is 3000, right. So that's why it is showing the 3000, means it is working fine. So if we had to group any of the column values, we can use a group by. Always remember we use with group by a aggregate function like count, max, mean, sum, average, like that. Similarly if you want to find out the what is the minimum value, you can use a min also. You can see min. So I hope you got the idea like how actually we can use a group by transformation in a PySpark. Hello everyone, so in this particular video we are going to continue the PySpark tutorial, and we are going to learn about the joining concept in a PySpark. Joining is a very much important from an interview perspective and from the job perspective also, because in organization you will see a multiple tables you will be having, and you have to join and you have to combine this all the data set. So in that case we have a joining concept that we are going to learn in this particular video. So PySpark join is used to combine two data frame. PySpark join operation combine data from a two or more data set based on the common column key. That is important. Based on the common column key, we try to join two or a multiple data set. So it is similar to the SQL. In a SQL also we have a inner join, left join, right outer join, full outer join, semi join concept, right? So here also in a PySpark also we have a same concept. So what is inner join, left join, right join, full outer join, left semi join, left anti join? Let's try to understand. So first I'll show you the data sets. I have a one department data set. In this department I have all the department related information like what is department, what is the designation, and also the user ID information. In the employee table I have all the employee information, their name, salary and location. This kind of information I have, and I want to combine these two. So let's understand. So what to make you understand, I have just combined. So this is my first data set, first data frame, and this is my second data frame. Now I want to combine these two. So what is the first thing we had to check? We had to check what is the common key. Based on that we can do a joining. In this case, what is the common key? Employee ID is common key, user ID is common key. Based on that I can do a joining. So first thing is like what is the common key? Based on that we can do a join, that we had to find out. Now second thing is like which operation we want to perform. So you can see we have a multiple, right? We have a inner join, left join, right join, full outer join. So let's see how actually it works. So joining, we used to combine these two data sets. So we are joining these two data set, and what is the final output we want? We want all the column, like we want employee ID, name, salary, location, as well user, department, designation, all. So in this case what we will use? We will use a joining. So what is the first joining? First joining is the inner join. So whenever we will apply a inner join, it will return only the row with matching keys in the both the data frame. So if you'll see, whatever the matching records will be there in the both the data frame, that only we will get all the records. You can see in the first table we have a 1 2 3 4, and in the second table also we have a 1 2 3 4. 5 6 is not matching, only 1 2 3 4 record is matching. So in this case what we will get? We will get all the matching records from the both the tables. So in the when we will apply a inner join, this will be our output. This will be our output. So in this case what will happen? Whatever the common key which is available in the both the data frame, that all the records we will get. 5 6 is not here, then that record we will not get. 7 8 is not here, then that record we will not get. Only the matching records we will get from the both the data frame. So that is a inner join. Second is the left join. In the case of the left join, by the name itself you can understand left. What is the left and right? Whatever the first data frame will be available, that you have to consider as a left. Whatever the second data frame you will be having, that you have to understand as a right. This is the right. So in the case of the left join, what happen? It will return all the row from a left data frame and matching row from the right data frame. So it will return all the row from a left data frame. So these are the record we have, right? So whatever the records will be available from the left data frame, you will get all those record, like 1 2 3 4 5 6, everything you will get. Whatever the matching records you will be having in the right data frame, that only you will get. You can see 1 2 3 4 only is available, which is matching from here, right? So that record only you will get. 7 8, this record we will not get because this is not available here. When we'll apply a left join, so it will return all the records from the left data frame, and only the matching records you will get from the right data frame, and whatever is not matching you will get as a null. This all the value will become a null because this is not available in the right data frame, right? So this value will be a null. Now let's see how actually we can apply a right join. In the case of the right join, by the name itself you can understand, when we are saying right join, so it will return all the rows from a right data frame and matching rows from the left data frame. In the case of the right data frame, what will happen? All the rows you will get from the right data frame, means all the records you will get from here, and only the matching records you will get from the left data frame. What is the matching record? This 1 2 3 4 only is matching, right? So that record only you will get, and this 7 8 is not available here, so this will become a null. This all the value will be a null. So in the case of the inner join, what will happen? Only the common records you will get, and in the case of the left join, all the records you will get from the left table, only the matching records you will get from the right table. In the case of the right join, all the records you will get from the right table, only the matching records you will get from the left table. Now we have a full outer join. It will return all the rows from both the data frame, including matching and non-matching rows. So in the case of the full outer, what will happen? You will get all those records. So you will get all those records from this table. This all the records you will get. and whatever is not matching, that will become a null. So you can see 1 2 3 4, this is matching, so this you will get. 5 6 is not matching, so this records also you will get, but this value will become a null. This all the value will become a null. Here this 7 8 is not available here, so this all the value will become a null. So like this actually works in a full outer join. So you will get all those record, only the whatever the matching, that only you will get. Other So in the case of the full outer join, you will get all those record, whatever is not matching, it will become a null. Now we have a left semi join. It return all the row from the left data frame where there is a match in the right data frame. So in the case of the left semi join, what will happen? Whatever the common records, right? Whatever the You will get only those records from a left data frame which is available in the right data frame, in a right data frame. So that is a left semi join. Left anti join, it return all the row from a left data frame where there is no match in the right data frame. So you can see the 5 6 is not available in the right data frame, right? So this only the records you will get in the case of the left anti join. In the case of the left semi join, it will give only the return of this all the 4 value. So this is the, because these are the available in the right table also, right? So in the case of the left semi join, this is the output we will get. In the case of the left anti join, this is the output we will get, because this is not available in the right table. So that we have to remember. Let's do a practical and let's understand. Now for practical, I have created a 2 data frame. One is a employee data frame. So I have an employee data, I have an employee column. Spark.create data frame, employee data and employee column if will pass, employee data frame will be created. So this is the first data frame I have created. Now I have also created a second data frame, that is a department data frame. So you can see this is the department data, department column, Spark.create data frame, and this is the department data frame. And now I have a 2 data frame. Now I want to perform a join. So you can see in employee data frame I have an employee ID, name and department ID. In the department data frame I have department ID and department name. Now if we'll join these 2 data frame, right, what is the common factor? We have a common factor, that is a deployment ID, department ID. Department ID is common in the both the places, right? So based on this we will perform a joining. So let's see how actually we can do a joining one by one. So first you have to write the first data frame. First you have to write the first data frame, that is a employee df, then dot join. Then you have to write the second data frame, that is a department data frame, and comma. After that you have to mention based on which actually you want to join. So in employee data frame I have a department ID, right? In employee data frame I have a department ID equal to the, in a department data frame also we have a department ID, and what kind of the joining we want to perform? I want to perform an inner join, so we have to mention this. What actually I am writing, employee data frame dot join department data frame, means employee data frame I am joining with the department data frame based on what? Based on the department ID which is present in the both the data frame, and I am performing a inner, so I am mentioning the inner. So this is the inner join. Now if you want to see that, dot show, if you write, right, dot show, and let me execute. Let's see it's working or not. It should join the 2 data frame and you should give the result. Now you can see it has joined the 2 data frame, whatever the common record was there, right? Now if I'll show you, whatever the common is present in the both the data frame, it is giving you the result. So you can see 1 2 3 is present into the first data frame also, and 1 2 3 is present into the second data frame also. 4 is not present. So whatever is matching, right, in the case of the inner join, we will get only those records. So you can see 1 2 3 1 2 3 only we are getting. Inner join means only the common record we will get. Now let's see how to perform a left join. So left join, it's very simple. Employee df dot join department data frame. Based on the department ID we will join. You only have to mention left here. If you mention left here, in this case what will happen? A left join will happen. So in this case what will happen? All the records from the left data frame we will get. So all the records, so this 3, right, these 3 are the left data frame, so all the records we are getting, and from the right data frame only this 1 2 3, these 3 are matching, right? So only these 3 we are getting, and the rest value we are getting as a null. So that is a left join. Similarly, if you see the right join, we have to mention the right here, We had to mention the right here. In the case of the right join, what happens? All the records you will get from the right table. So you can see this is a right data frame, right? In right data frame we have 1 2 3 4. So all the values we can see. In the left data frame, whatever the value which is matching, right, that only we are getting, otherwise we are getting as a null. So this is a right join. We also have a full join, full outer join. So in a full outer join, what we have to write? Instead of the right, you have to mention the outer. This is a full outer join. This is a full outer join. Full outer join. Outer join. Now in the full outer join, what happens? All the records from both the table we will get, and whatever is not matching we will get the null. So you can see 1 2 3 4 we are getting here, and all the records from the left also we are getting, and whatever is not matching it is coming as a null. So that is a full outer join. We also have a left semi join. Left semi join. You just have to mention left semi join. So the records from the left table, whatever is matching, we are getting the record. We also have a one more, that is a left anti join. This is a left anti join. Whatever is not matching right from the right table, we are getting those record. So this is a left anti join, and this is a left semi join. So I hope you got the idea how to perform a join into the PySpark. Hello everyone. So in this particular video we are going to see about the union and union all transformation. So union and union all transformation, generally we use to merge two or more data frame of the same schema or structure. For taking example, suppose I have one data frame 1, I have second data frame 2, and these two I want to combine, then I can use a union and union all. It is similar to the SQL. In a SQL also we perform a union operation, right? Here also it works in the same way. Let's take with the example. Suppose I have a two data frame. This is my first data frame where I have a employee ID 1 to 6 information. I have another data frame. Here I have a 7 to 12 information. You can see schema also the same. We have a employee ID, name, salary, and the location column. Here also we have a same employee ID, name, salary, and location column, and their data types and everything is same. And we have a same number of column available in the both the places. Now this is the scenario is like we should have a same schema and the same structure. So you can see we have a employee ID, he name, salary, and the location. Similar kind of the structure is also available here, and the data type is also almost same. Now if you want to combine these two, then we can use a union. So whenever you will combine this, so what will be the output you will get? You will get the output like this. So you will get the first and then the second, means all the records you will get. So this is a union. So with the help of the union, this will be the output I will get. This will merge two data frame, and this will be the output of the all the records we will get. So let me open my Databricks account. Now let's do a practical. For practical, I have created a two data frame. So this is the first data frame. If I show you the data, so we have a data, we have a column, and based on that I am creating one data frame. In this data frame I have a two record 1 and 2. I have created another data frame, that is a data frame 2. This is the data, and here we have a 3 4 and the 2. Now these two data frame we had to perform a union. In these two we had to merge and we had to perform a union, right? So how to do a union? What you have to write? You have to first mention you are the first data frame. What is our first data frame? First data frame is df1, right? df1 dot union, df1 dot union, and after that we had to mention the df, what is your second data frame, df2. Now to see the result, right, dot. So if you'll do, if in this case what will happen, these two data frame will be merged on a row basis, and all the record we will be able to see. Now you can see we are able to see all the records from both the data frame row by row. If you had to merge, then you can use a union operation. Now as of now you can see in this, when we have performed a union, right, one record is a duplicate record. So how actually we can handle this duplicate record while doing a union? So what you have to mention, df1 dot union, df2, df2 and after that we had to mention dot string dot show. Now if I'll execute this, now in this case what will happen? Only the unique record we will be able to see. So it's very simple, right? Union. I hope you got the idea. Please do practice. Hello everyone. So in this particular video we are going to discuss about struct type and struct field in a PySpark. So in high level, if I'll say, suppose you have given one CSV file. In that CSV file only data is given. What is the column that is not given? Like ID, it should be ID, it should be a name. Like that column itself is not available, only the data is available. Now you want to define the column name, you want to define what will be their data type, you will define whether the null value will be a true or false. So in that case what actually we use, with the help of the struct type and the struct field, we can explicitly define column name should be ID, column type should be integer type, null value should be a false. Like that explicitly if you want to define the schema, then what we use a struct type and struct field in a PySpark. Now what is the difference between the struct field and the struct type? Struct field, for one column, for a specific one column, what will be a column name, what will be their type, then what actually we use for a specific one column only. If you want to define the schema, then we use a struct field. Now what is the struct type? Struct type is nothing but it is a group of struct field, you can understand. So on the definition on top you can see, like struct type is like a list of struct field. So you can see here we have using a struct type. Under the struct type we have a multiple struct field, like multiple columns and their data type we can define. So struct type is a group of struct field, you have to understand. And what is a struct field? It describes the name, data type, and what will be the nullable condition. So whenever you have to define explicitly the schema of your table, like what will be a column name, what will be a data type, then we use a struct type and the struct field. I'll show you with the example. Suppose I have a one data. So as of now this data is given to me. This data is given to me. Now on column is not given. Now what actually I have to do? Suppose this one is representing the ID, this is representing the name, this representing the age, but the column itself is not available in a CSV file. Then what actually we can do? We can define a schema like this. So you can see I am defining a schema. I am writing a struct type. Under the struct type I am writing a struct field. So the first column should be ID, the type should be integer type, and the nullable will be a false. Similarly, the second column will be a name, type will be a string, and the nullable will be a true. The third column will be a age, type will be a integer, and nullable will be a true. So like that actually we can define the schema. And if we'll create a data frame, right, spark.create data frame, data you have to pass and you have to pass the schema. So whatever the schema we have created here, right, that schema we are passing. Now if I'll execute and if I'll show you, this one is not required, let me delete this one. So you can see we are also importing few of the libraries, that is important, that you have to remember. From PySpark.sql.type we have to import the struct type, struct field, string type, integer type. This all we have to import, then only we can use here. This is the one of the library. From this library we have to import this integer type, string type, struct field. Then we can create a schema like this, and then we can create a data frame. Now if I'll execute this, right, now let me execute. Now what will happen? The proper schema will be created. So you can see I have done the df.show also, and also I have done the df.print schema. So you can see ID, name, age. ID is integer because we have defined the integer, name is string, and the age is integer, and also whatever the nullable condition we have defined, right, that also is coming nullable, false, and all. So for given a data, if you want to specify the schema, then what we use a struct type and the struct field. Now let's take one more example. I will just take a random file. This is not a file we have uploaded. What actually I am saying, suppose you have a scenario, you have a CSV. In that CSV the column name itself is not available. The column name you had to specify by you. Then what actually you have to do, what actually you can do, in that CSV file only the data is available. So what actually I am doing, first I am importing a library from here. I am importing the struct type, struct field, and all. And after that what actually I am doing, I am defining one schema, because column name and what is the column type, this all the schema is not available in my CSV file. So I am defining a schema, struct type I am writing. Under the struct type, struct field I am writing. The first column will be ID, it should be integer type, then name, string type, then the age integer type, then the salary integer type. This all the thing I am defining. Now how actually we create a data frame while reading the CSV file is spark.read.csv and the whatever the file name, right? This is nothing but this is a volume. If you will upload any file, so here nothing but this is a volume location. I haven't uploaded any file, I'm just showing you the example. So this is the location you will pass, right? Spark.read.csv and the location. Header equal to true we had to pass, and the schema equal to the schema we had to pass. So this is the schema, right? Whatever the schema we are writing, this we have to write schema equal to the schema. Once you will do this, right, once you will execute with this particular schema, your proper schema and the column name will be available in your CSV file. My requirement was I have a CSV file, but there no column was available. So what actually I have done, I have created one schema for this. I have defined the schema, and while creating a data frame and also passing the schema equal to the schema. Now once you will execute, you will get the proper data. With column you will get the proper data frame. So like that actually we use a struct type and the struct field whenever you had to create a proper schema for your data frame. Hello everyone, so in this particular video we are going to see about the pivot and unpivot operation and how actually we can perform in a PySpark, that we are going to see. So let us first understand when we have to perform a pivot and when we have to perform an unpivot. So pivot operation means whenever you have a row values and that row values if you want to convert into the column, then you will use a pivot operation. And unpivot is just opposite. So in the case of the unpivot, whenever you have a multiple column value and that column value you want to convert into the row, then you will use a unpivot operation. Let's take an example. Suppose I have a data like this. In this data you can see I have a product, amount and the country. In this case you can see in the country we have a India, China, USA. So this row value if you want to convert into a column, then what actually you can use a pivot operation. We have a pivot function in a PySpark. So suppose I want a output like this. I want output like I should have a product column, I should have a one column for the India, I should have one column for the China, I should have one column for the USA, and this corresponding value will represent here. Here it will be the value and here it will be the product. Means what actually I am doing, this row value I am converting into the column. So in this case what I will use, I will use a pivot function which is available in a PySpark. So one thing we have to remember, based on the unique value which is present into this column, right, that value only will convert into the column. So that is the one thing you can remember. You can see in the country we have a India 2 times, right, but based on what is the unique value here, India, China and USA, these are the unique value, right, so that only will convert into a column, not all the value. So whenever you have to convert row value into the column, then you will use a pivot function. Unpivot is a just opposite. Suppose you have a data like this, product India, China and the USA. Now this multiple column if you want to convert into a row, then what you will use a unpivot operation. So for to perform unpivot operation, we have a one of the library expr in a PySpark. So that actually we will use, and with the help of that we can perform an unpivot operation. So pivot operation, whenever you have to convert row into the column, then you will use a pivot. Unpivot, whenever you have to convert multiple column into a row, then you will use a unpivot operation. Let's do a practical and let's understand. Now let's do a practical of pivot and unpivot. So I have a data and I have a column. With the help of this I am creating one data frame, spark.create data frame. I am passing the data and the column, and if I'll show you my data frame, so as of now in a data frame I have a region, I have a product, I have a quantity. Now what is my requirement is like I want to do a pivot operation, means in the product, right, in a product whatever the value is there. So for laptop I want to store all the values into a separate column, for phone I want a separate column, similarly tablet I want a separate column. So how actually I can do that? As of now this all the values are coming in the form of rows, right? So as of now you can see this laptop, phone, laptop, tablet, these are the values coming in the form of rows. But for laptop I want a separate column, phone I want a separate column. How actually we can do? For that we use a pivot operation. So what you have to write, df dot group by. First we will do a group by based on the which particular column, the region column. So region wise we will try to group and after that we will write pivot. Which particular column? This product column, right? We want to do a pivot, so I will write a product here, product, and after that whatever the quantity, right, this we will do a sum of quantity. Now if I show you, now in this case what will happen, you can see this. For laptop the separate column got created, for phone separate column got created, tablet separate column got created. If I show you, so you can see in the west is the region, right? Previously a laptop 7 it was coming in the form of row, right? West and west. Now you can see west, for the laptop we have a 7 quantity, for tablet we have a 3 quantity. In the west region we don't have any value for the phone, that's why it is coming null. Similarly for the north, you can see laptop is 10, so laptop is 10 coming. Similarly phone is 20, it is coming. There is not tablet, so it is coming null. So if you have any kind of the requirement where you want to convert from a rows to a column like this, then we can use a pivot. Now let's see about the unpivot. So in unpivot, what actually I will do, first I will try to store this into a one data frame. So I will give the name as a df1. I will store the same data frame. I will use a df1 dot show. Now what is my requirement here is like, now I want to do a unpivot operation. Unpivot operation means I have a data frame like this, region, laptop, phone and tablet. Now suppose your requirement is like whatever the value is coming in the column, right? This you want to convert into a rows. This laptop should come in the form of the rows. Means we want output like this. If you have a data frame like this and you want output like this, from a column to rows you want to convert, then what actually we use a unpivot. So for unpivot we have to import one library. Let's see that. So what you have to write, from PySpark dot SQL dot functions import expression expr. After that you have to write df1 dot select what are the column you want. I want a region column as it is, so I will write a region. After that I will use a expression. What I am writing, I am writing a df1 dot select expression. Under this I will write stack. So in a stack we have to pass like how many values are there in a column. You can see we have a 3 values, right? So in a stack I will pass 3. Now you can see this laptop, right? This laptop will go into the product column, so the value will be a laptop only, right? So in a single quote I will write a laptop. And this all the value, right? For laptop value this will go into the separate column as a quantity. So what I will write, I will write laptop as it is. So what I am writing, this laptop value, right, this will go into the product. So that's why I am writing in a single quote laptop, and whatever the value, right, this will go into the quantity column. So the laptop column name as it is I am writing. Similarly for others also I will do. You can see phone, tablet, it is coming like this. Now so this value go into the product, right? So I will give the name as a product, and this value will go into the quantity, right? So I will mention the quantity. Now if I'll do dot show, now if I'll execute, what will happen, you can see it get converted into from a column to a rows. So you can see, so from a laptop, right, laptop is 7, for west laptop is 7, for west phone is null, right? For west phone is null, for the west tablet is 3, for west tablet is 3, like this it is coming. Means whatever this value was there, that we have stored into the product column, and whatever this value is there, that we have stored into the quantity. So you can see here we have a 3 column, right? So in a stack we have mentioned 3, and whatever we want to store into the product, right? These are the value. This we are passing into the single quote, and whatever we want to store into the quantity column, right? This we are passing as it is, like laptop, phone, tablet. So like this actually we can do a unpivot operation. Please do a practice. A little bit tricky, but most of the time we don't use this all the function. But suppose if you have a rare scenario, then you can use this. Please do remember this and please practice. Hello everyone, so we'll continue our PySpark tutorial, and in this particular video we are going to see about the UDF user defined function in a PySpark. So how actually we can create a UDF function in a PySpark we are going to see, and what is the use case that also we are going to understand. So let us understand. It is a most useful feature of a Spark SQL and data frame that is used to extend the PySpark built-in capability. Let's take an example, and with that example let's try to understand. Suppose let's take one scenario. Suppose you have one of the data frame. In this data frame you have a multiple column, like column 1, column 2, column 3, like that you have a multiple column. Now one of the column is representing the timestamp, like you have a date and also the timestamp format. The data is available like 23 1 2 0 0 0, like that you have a timestamp. In the timestamp you are getting a data. Now suppose your requirement is like you have to convert this timestamp into the date. Then what actually you will use in a PySpark, we have a few inbuilt functions are available. So what actually I will use a toDate function, and I will pass this column. Now what actually it will do, it will try to convert my timestamp into a date, and I will get a result like this 2024 06 and the 12. So this is the output I will get when I will use a toDate. So from timestamp to date, if we had to convert, then what actually I was using a toDate inbuilt function which is available in a PySpark. Now suppose you have a specific requirement, and for that specific requirement there is a no inbuilt function is available in a PySpark. Then what actually we can do, we can create our own function. And how actually we can create, with the help of the UDF user defined function, we can create our own function, and then function we can use anywhere in the data frame, like we can reuse that function multiple places. So that is the advantage we get in a UDF. So if you already have a built-in function available, then you can directly use. But suppose if you have to create your own function, then what actually we'll use, with the help of the UDF we can create that. So UDF are used to extend the function of a framework and reuse this function on a multiple data frame. Now let's take an example. Suppose you have a requirement. Now suppose you have one of the column. In this column you are getting all the name like this Manish, Rani and all. Now what is your requirement? You want to convert this first letter into a capital case. So like this actually you want the output, like the first letter should be in capital, and like that this is the output you want. So for this we don't have any inbuilt functions available in a PySpark. So what actually we can do, we can create our own function with the help of the UDF. We can write our Python code, and with the help of the UDF function we can reuse that function in a multiple places. So that is the advantage we get. One thing you have to remember, UDF are most expensive operations, hence we have to use them only you have no choice and when essential. Whenever it is a very much essential and there is no other choice, then only use a UDF, because it is a most expensive operation from the computation perspective. So that is the one thing you have to remember. So let's try to do a practical and let's understand. Now let's see how actually we can create our own UDF function. So suppose you have a specific requirement, and for that specific requirement we don't have any inbuilt function which is available in a PySpark. Then what actually we can do, we can create our own UDF function. For taking example, I have one of the data frame. My requirement is like, based on the age, it should automatically find out if the age is less than 18, then it should group as a minor. If the age is between 18 to 40, then it should consider as an adult. If the age is greater than 40, then it should consider as a senior. This is my specific requirement I have. So if anyone is giving me age column, then based on the age column I should be able to find out if age is less than 18, then I will categorize as a minor. If the age is between 18 to 40, I will categorize as a adult. If the age is greater than 40, then I will categorize as a senior. This is a specific requirement I have. Now in this case what I will do, I will create my own function. So what I will write, I will write df. I am going to create a function like how actually we create a in Python. I am going to create one function age group, and here I will pass a number. You can give the num, or let's give the name as a age. So if anyone will pass any age, based on that we will try to categorize. So we will give one condition: if age is none, then we will return as a unknown. If the age is less than 18, then we will return as a minor. If age is between 18 to 40, then we will consider as a adult. Otherwise we will return a senior. So this is a one function I have created. This is one simple how actually we create in a Python. I have created one function. Now to test it, so suppose I will pass I will call this function, I will pass any number. Suppose I will pass a 40. So if you will pass any number here, right, based on that it will consider it is a senior. So suppose I will pass a 39, then it will come into the adult category. Suppose if I will pass a 10, so you have to pass the number, you have to pass the age, and based on that you can see different category we are getting. So we have created one function. Now if you have to use it anywhere in your data frame in a PySpark, right, we have to register our UDF. So for that, what actually we have to do, we have to import few library. If you have to use a UDF function, after creating a function you have to register also. So that is the thing you have to remember. So what I will do, I will import a few library from PySpark.sql.function. I am importing a UDF. This is a function I am importing, and also I am importing from PySpark.sql.type. I am importing a string type. Now if you have to register your function whatever you have created, right, let's try to register it. I will give the name as a age group category something. This name I will give age group category. This is what I want to create. Now what I will use, I will use a UDF function, and I will try to register my function which I have created. So what is my function name? My function name is age group, right? This I want to register. So in UDF I will pass the age group, and the type also we have to pass. So whatever the output we are getting, the minor, adult, senior, these are the string type, right? So that's why I will pass the string type. So this is how actually you have to register your UDF function. Let me execute this. Now my UDF function will be registered with this name, this age group category. With this my UDF function will be registered. Now if you will pass any of the age, so based on that it will categorize the group. So suppose in this data frame we have a age column, right? Based on the age it will categorize the age. Let me show you. So suppose if I will use a df dot with column, I want to create a new column name as a age category, and after that I'll use this particular function which we have registered, right, this one, and which particular column we have a age column, right, this I will pass. Now if I'll do dot show, if I'll execute this, what actually we are doing, we are passing a age column value here. Based on that what actually it will do, it will categorize it and it will give you result. So you can see if it is a, if the age is 10 it is categorizing as a minor, if it is a 25 then it is categorizing as an adult, if it is a 60 then it is categorizing as a senior, if it is a null it is categorizing as a unknown. So now we have created one UDF function, and now anywhere we can use this UDF function. Anywhere we can use this ADF function. It is like a built-in function, like how we have a different built-in function like upper, lower. These are the different inbuilt function we have, right? Similarly, we have created one our function. The function name is age category. This is the function we have created. This we have created. Here you will pass any of the age value, you will get the result. You will get the age category. So I hope you got the idea how to create a UDF function and the use case. Hello everyone, so we'll continue our PySpark tutorial, and in this particular video we are going to learn about the temporary view. How actually we can create a temporary view in a PySpark, that actually we are going to learn. It is a very much important and a useful topic, because once you will learn this topic, then if you are good in a SQL, then you can write any kind of the SQL query and you can achieve your result. Means what actually happening with the help of this temporary view, you can convert any of the data frame into a table, and in on top of this table you can write any kind of the SQL query. So if you are good in the SQL query, then you can convert any data frame into a table. On top of that table you can write any kind of the SQL query, and then you can perform all the kind of the data cleaning operations, all the kind of the thing you can do that. So that is the advantage we get. So let's understand. So create or replace temp view. With the help of this we can create a temporary view. We can create a temporary view. We are writing temp, right? This means we are creating a temporary view. What is temporary views? Temporary views are a virtual table. It is not a physical table which is stored anywhere. It is like a temporary table that you have to remember. It is like a virtual table. They are not stored in the catalog or only visible to the current session. So only on the current session you will see that table, like temporary table will be available. Once the session will end, you will not be able to set that temporary view. So that is the thing we have to remember. Temporary view allow you to reuse the result of a complex query or data frame without creating a permanent table. So with the help of the temporary view, we can reuse any of the data frame or the complex query if you have written, that actually you can reuse again and again with the help of the temporary view concept. So that is the thing. So what is the use case? With the help of the create or replace temp view, we can convert any of the data frame into a view. It's kind of the temporary view. It will not be a permanent. During that session, one virtual table will be created, and on top of this virtual table we can write any kind of the SQL query. We can write any kind of the SQL query, and after that if you have to perform any kind of the analysis, or if you have to do any kind of the data cleaning, you can write any kind of the SQL query and you can get that. Once the session will end, this temporary view will not be accessible, so that you have to remember. So let's do a practical and let's understand. Now let's see with practically how actually we can create our temporary view. So I have one of the data and I have a column which is given. Now what I will do, I will create one data frame. So how actually we can create a data frame? You have to write spark dot create data frame, and we have to pass a data and column. Spark dot create data frame, data and column you have to pass, and df dot so if I'll do, let me execute and let's see how our data looks like. So this is the data we have. Now what actually I want, this data frame I want to convert into a temporary view. So what we have to write, df dot create, you have to write df dot create or replace temp view. You can see df dot create or replace temp view, and what is the temporary view, that name you have to pass. So suppose I will pass the temporary view name as a test. So what will happen, with the name of the test, one view will be created, and this will be a temporary view. Let me execute this. So one test view got created. Now if I'll execute it, now I can write any kind of the SQL code also. If I'll show you, if you have to write SQL code, as of now our language is Python, right? But if you have to execute the SQL, %SQL you have to write. Now you can see view got created, right? Now I can write any SQL code. Select star from test. If I'll do select star from test, let's see whether it is working or not. Let's see whether view got created or not. Now you can see view, we have created a view with the help of the data frame, with the help of the create or replace temp view command. Now you can see I am able to execute the SQL code. So we have created one test temporary view, right? I am able to execute the SQL command, select start from temp. So like this actually we can create a temporary view. I will show you another example. Suppose I will create one more data frame. So we have a data we have uploaded into one of our volume, right? So let's try to read that. So what I will write, spark.read.parquet, and after that we have to pass the location. So how to pass the location? So where your data is available, in a catalog we have uploaded, right? In a development catalog we have one of the volume. Let me show you. In the database we have a file volume, and I want to read this a parquet file, this one. So I will pass this location here. So you can see in a double quote I will pass this particular location. Now what will happen, data frame will be created, right? I will create one temporary view. create or replace temp view, and the view name I will give as a orders. Now let me execute. Now what actually we are doing, we are reading this particular file and we are creating one temporary view order. Once it will be created, we can write any kind of the SQL code and we can utilize the SQL functionality. So now it's created. If I'll show you, select start from orders. If I'll do, I should be able to read the file and I should be able to get the data. Let's see it's working or not. You can see I am able to write all the kind of the SQL code. So you can see all the data I am able to read. Any kind of the SQL code if you want to write here, right? You can do that. Now suppose you want to find out count, or suppose you want to find out the count of distinct order ID, count of distinct order ID, like that. Any kind of the thing you can write, minimum of order date, any kind of the SQL code you can write. So like this, any data frame if you have to convert into the temporary view, so what actually we can do, we can use a create or replace temp view command. We have to pass the view name, and that view actually you can use it for the any SQL query. I hope you got the idea how to create a temporary view. Hello everyone, so we will continue our PySpark tutorial, and in this particular video we are going to see about the Windows function in a PySpark. It is a very much important topic and the useful topic, so we should know about the Windows function. In a SQL also we use a different Windows function like row number, rank, dance rank, lag, lead. In a PySpark also we can use the same one. So that actually we are going to discuss like how actually we can use the same row number, rank, dance rank, lag, lead in a PySpark, that we are going to see. So if I show you in a SQL how actually we use a row number, so we write a query like this: select row number, and after that if you had to group by any column, then we write partition by, and if you had to order based on the certain column, then we write order by salary, and we create a new column, write RN or something name you can give, and based on that we try to filter. So the use case is like, suppose I had to find out the fourth highest salary. So in this case what I will do, I'll use a row number, I will assign a rank based on their salary, based on the descending order of the salary. Now you can see based on their descending order of the salary I assign the rank. Who is the top is the 40,000 in highest salary, so I assigned a rank 1. Who is the second? So 34,000, so for this I assigned a rank 2. So like that, based on the their salary order I assign a rank. So if anyone is saying like to find out the fifth highest salary, so then what I will do, select star from this table where row number equal to the 5. So this row number column we had to derive. So how actually we can derive? With the help of this query actually we can derive this row number and the rank. And then if anyone is asking like to find out the fourth highest salary, then we will do select star from table where row number equal to the 4, then you will get the fourth highest salary. If anyone is saying like to find out the second highest salary, then what we will do, select star from table where row number equal to 2, then we will get the second highest salary. So this is the very useful case which generally get. So there are different use case, like we have a row number, rank and dance rank. So based on the use case actually we use, suppose you have a duplicate scenario, so in this duplicate scenario we use a dance rank and the rank concept. So you can see 20,000 and the 20,000. So in the, if you use a row number, then it will assign a all the number in a sequential manner. You can see both the 20,000 are the same salary, right? But it assigned the rank 3 and the 4 randomly. But when you will use a dense rank and if any duplicate value is there, so for the duplicate value 20,000 it will assign the same rank. You can see it assigned the same rank 3 and 3, and after that fourth is coming and then fifth is coming. But when you will use a rank, it will assign the same rank for the 20,000. You can see it assigned the 3 and 3. After that the fourth rank should come, right? But fourth it will skip because we have a duplicate entry, we have a duplicate record, so it will assign the same rank and then it will skip the 4 and it will directly assign the 5 and then the 6. So these are the different use case we have. In that case we use a different kind of the Windows function like row number, rank, dance rank. we also have a lag. So if you have to suppose find out the previous value, then we use a lag. If you have to find out the next value, then we use a lead function. So these are the different Windows functions are available in a SQL and in a PySpark also. So let us see how actually we can use in a PySpark. So let me open my Databricks. Now let's see with practically how to write a PySpark code for the Windows function. So one by one we will understand about row number, rank, dense rank, lag and the lead, and how to write a PySpark code for that. So I have one of the data frame. You can see we have a name, we have a department, we have a salary. Now let's see how to write a PySpark code for the Windows function. So we will start with the row number. What is a row number? When you will use a row number, right, it will assign a unique sequential number. So whenever you have a requirement, suppose my requirement is like based on their salary, from highest salary will get a rank 1, then second highest salary will get rank 2, then the third highest salary person will get rank 3. Means I want to generate the sequence of number based on their highest salary to the lowest salary. So in this case what I will use, I can use a row number. So row number, what actually we use in a SQL, right, it works in the similar way. First I will show you in a SQL how to use a row number, because whatever the code we write in a SQL, right, in a PySpark also it is similar to that only. So if you had to write a SQL code, then what actually you have to do first? First you have to convert your data frame into a view. So what I will do, I will convert my data frame into a view and the view name is employee. Now after that one view will be created, and after that I will be able to write any kind of the SQL code. So suppose if I write select star from employee, I should be able to see the data. Whatever the data frame we had, right, we have converted into a view and I can see that. Now in a SQL we are able to write a SQL code. Now in a SQL, if you have to write a, if you have to use a row number, then what kind of the code we write? We create a new column. Suppose the column name is, we will give later. So select star comma row number, open a bracket, close a bracket, and after that you have to write over. And suppose you had to group based on the any of the column, then what we use a partition by. We use a partition by department. And suppose we want to generate a unique number based on their highest salary to the lowest, right? So I'll use order by salary and the descending. I will give this name as a RN. So this is the new column we have created. This will generate a unique number based on their highest salary to the lowest salary. It will assign a rank. So whatever the highest salary person, that will get assigned a rank 1, then the second highest person will get assigned rank 2, like that. Now if I'll show you, we are using a row number in a SQL. So this is the code we write. Now you can see for HR department, the highest salary person 5200, right, assigned a rank 1, then second highest salary person got assigned rank 2, like the 3, 4, 5, 6 and all. Similarly, because we are grouping based on the department, right, now for the sales department, whoever is the highest salary person, that will assign a rank 1, then rank 2, rank 3, like this. So like this actually we write a SQL code. So in a SQL, if you have to use a row number, what actually we use? Row number over partition by department. If you have to group any of the column, then order by salary, descending. Now in the similar, in a PySpark also we write in the similar kind of the code. In a PySpark also, if you have to write a code for the row number, what actually you have to do? First you have to import a library. So what I will write, from PySpark dot SQL dot window import window, and after that from PySpark.sql.function dot function import star. If you write import star, means all the function it will be imported. Now after that I will define one variable w and write, this is the window, this we have imported, right? So I will use this window dot partition by. So in a SQL also we were doing a partition by, right? So here also we'll write partition by department, and after that dot order by salary. Now if you write order by salary, right, but we want a salary should be from descending to the ascending order. So if you have to do as ascending descending, then you have to use a call. Under this call you have to write a salary, call salary dot desc you have to write, desc you have to write. So what we have write, window dot partition by department, order by salary descending, this we have written. Now in the data frame we will add that df dot with column, we'll create a new column, right, rn, and here we will use a row number, row number dot over, and whatever the w is there, right, in a w equal to the this all, so dot over w we will pass. That's it. It's similar to the SQL only, right? Now if I'll show you the data, it will also give you the same result. So you can see a highest salary person got assigned rank 1, then rank 2, then rank 3, rank 4. Similarly for the sales department, highest salary got rank 1, 2, 3 and 4. So in a SQL, whatever the code we write, right, if I'll show you in a SQL how actually we have written row number and then over partition by department, order by salary. Here also we have written in the same way. If I show you what actually we have done, row number dot over, and w is nothing but a this all, partition by department, order by salary. So like that actually we use a row number. So whenever you have to generate a unique number, then what actually we use a row number. If I'll show you in a row number, right, so you can see this employee salary is 5,000, this employee salary is also 5,000, but what actually it is doing, it is randomly generating a unique number 4 and 5. Their salary is same, ideally it should be the same rank, right, but you can see it assigning the unique number for each record. Now if you have a duplicate record like 5,000 5,000 is same, right, in this case you want to assign a same rank, then in that case what actually we use a rank and the dance rank concept. So let's see. So for rank and the dance rank also we write a same code. If I'll just copy this, only one place we have to change. Now we will see about the rank. So in a rank, what you have to do, instead of the row number you have to just write a rank, write a rank. Now if I'll execute this code, now let's see how actually it is happening. Now when you are using a rank, right, in this case what is happening, you can see 5100 5100, this both got assigned the same rank. First rank is 1, highest salary employee got a rank 1, the second highest salary we have a 2 employees, so both got the second rank. But after that the 3 should come, right, because 2 employee got the same rank, then what actually it will do, it will skip the 3 and it will directly assign the rank form. So like that actually it work in the case of the rank. If I show you another example, for the sales, highest employee got rank 1, then we have a 2 employee, the salary is same, so both got the same rank. After that the 3 should come, right, but the 2 employee got the same rank, so that's why the 3 got skipped and the 4 it actually it is starting. So like that actually it work in the case of the rank. Now let's see in the dance rank how actually it works. So if you are using the dance rank, right, it also will work in the same way. So instead of the rank, what you have to write, you have to write a dance rank, you have to write a dance rank. Now if I'll execute and if I'll show you, in the case of the dance rank what will happen, you can see highest salary employee got rank 1, then second highest salary got 2. If their salary is same, right, 51 5100, both got assigned the same rank. Then after that the third employee got assigned 3. When you are using a rank, right, in this case what actually was happening, it was skipping because 2 employees having a same salary and the same rank, then it was skipping. But in the case of the dance rank it will not skip, another employee will get the third rank, fourth rank, like this. So like this actually it works. In the case of the rank, in the case of the rank you can see 5100 5100 2 employee, right, so it got assigned the same rank. After that 3 is it is skipping and directly it is giving the 4. But if you use a dance rank, what will happen, it will not skip any of the number. If the 2 employees having same salary, both will assign the same rank. After that the next employee will start with the next number, that is a 3. So like that actually dance rank works. Now let's see how actually we can write a code for the lag. So when actually we use a lag, whenever you have to find out the previous salary, so you can see this is the 5100. What is the previous salary of 5100? 5200, right? Similarly, what is the previous salary of this? The 5100 is this, right? So if you had to know the previous record, then what actually we use? We use a lag. So the code is similar only. What actually you have to do, instead of the dense rank, you have to pass the lag, and under this lag you have to pass the column. So I will pass the column salary column. I will pass the column as a salary, and I will give this as a 1 salary 1. What you have to write? You have to write a lag, and you have to pass the salary 1. And if I'll execute this same code only, what actually it will do? Lag will just give you the previous record. So you can see what actually it is giving. What is the previous record of the 5100? It is a 5200, right? So I am getting the 5200. What is the previous record of the 5100? It is a 5100, so I am getting the 5100. What is the previous record of the 5000? It is a 5100, so I am getting the 5100. So whatever the previous record, if you want to know that, then what actually we use a lag. Why actually we are getting a null? Because this is the first record, right? Before to that we don't have any record, that's why we are getting a null. So like that actually the lag works. Now let's see, we have a lead. Now suppose if you want to know the next record, what is the next record, then what actually we use a lead. So instead of lag we will use a lead. If I'll execute this, what will happen? We'll get the next record. Now if you'll see the 5200, what is the next record? This is a 5100, right? So 5100 actually I'm getting. What is the next record of the 5100? It is a 5100, right? So I am getting the 5100. This for third employee, what is the next record? 5000, right? So 5000 is the I am getting. So whenever you want to know the what is the next record, so in this case what actually we use a lead. If you want to know the what is the previous record, then we in that case we use a lag. So I hope you got the idea. The code wise it is very similar and it is very easy. If you will do practice one time, all the codes are same only the thing is like you have to understand the concept. Whenever you want to generate the unique number, then go for the row number. Whenever you have a duplicate record and the same kind of the rank, in that case you can go for the rank and the dense rank. Lag we use whenever you want to know the previous record, and lead generally we use whenever you want to know the next record. I hope you got the idea. That's it, so thanks. Hello everyone, so in this particular video we are going to understand about date format in a PySpark. It is a powerful tool for transforming and for formatting a dates. Let's take an example. With that example, let's try to understand. Suppose you have given of the data frame. In this data frame you have one of the column that is representing the date, and suppose you are getting a data like this, like you are getting a data like this 2024/0405. Now your requirement is like your stakeholder wants your data in this format, like it should be 04 and dash and 05. Then how actually you can do this actually we can achieve with the help of the date format function which is available. Now suppose you want to convert this particular date in this format, like you want April and 05 like this. That is also possible with the help of the date format. Like whatever the date format you want, you can convert with the help of the date format function which is available in a PySpark. This function allow you to convert a date and timestamp columns into a specific string format, and it providing the flexibility to various date manipulation tasks. So any kind of the date manipulation task you can do with the help of the date format function which is available in PySpark. Let's take an example. Now let's do a practical and let's understand how actually we can use a date format in a PySpark. So I have one of the data frame. You can see in this data frame I have ID, I have a date. Now what actually I want this date, whatever date we have, right, as of now this particular date, I want to convert into another format. For example, suppose I want to convert into a, as of now you can see dash is there, I want to convert into this particular format in the form of the slash. What actually we can use a date format for that. And also there are certain other use case also, we will try to explore that. So if you have to use a date format, first you have to import a library. So what I will use, from PySpark dot SQL dot functions, we have to import everything. Import star. After that we have to use df dot select. What are the column we want? We want a ID column as it is, we want a date column as it is. Now we want to create a new column, there we will use a date formats. So date format I will use. After that, which particular date column you have to use? This one. This particular date I want to change a format. Which particular format you have to pass? So I want into this particular format YYYY MMDD into this particular format. Now after that we will use a dot show. Let's see it's converting or not. So what will happen? So we are converting into this particular format. So you can see previously the date was in this particular format. We have converted into a 2025-08 and the 23. Now if you want, as of now it is showing 08, but suppose you want to show in the form of January, February, March and all, so what actually you can do that also is possible. So what you have to write, you have to write the same code. Let me copy paste again. So instead of if I'll pass triple M, and let me show you how actually it works. So you can see now it is showing like August, December, January, July, like this. So 08 is for the August, right? So that's why AUG it is showing. Now if you'll pass one more M here, so if I'll pass one more M here, now if you'll see, right, now it converted 2025 August, December, January, July. So like that the multiple format you can convert. Now suppose what actually I want, we have a data as of now like this, right? Now what actually I want first the date should come. First I want first the date should come. DD I will write. Then I want a MM, and then the year. I want into this format. Let's see it's working or not. So now you can see first the date is coming, then month is coming, then year is coming. Like that we can convert also. So suppose here also if you want to change, right, if you want to change anything like this, that also you can do that, like 23 August 2000, like this. Now suppose this one we want into this particular format, 23 August 2025, like any of the format which you want you have to specify here, and that particular date column will convert into that particular format. So I hope you got the idea about the date format in PySpark.